Hello everyone, this is Randy again from Programmer Zen, and today I want to teach you how to make a game using SwiftUI. It's going to be a two-player game where you're going to play against a computer. So the computer is going to try to outsmart you, and it's got sound and graphics, and it's a complete game. So let's get started. So before we go any further, let's see what this game is all about.
Let's play.
It's a two-player game. It's called In Between. It's going to deal you two cards, and you're going to bet on whether you think the middle card's going to be in between or not.
Ante up.
First thing you got to do is ante.
Player one.
Player one.
You're up. Player one. Make your bet and hit me.
I'm going to bet it all. I'm either going to win or I'm going to lose. So I lose.
Player one. You lose.
And
Player two wins the pot. Game over.
And that's basically what it's all about. Okay, so let's get started. Let's create a new project. It's going to be an app. We are going to call it In Between. Now, you may or may not have a team, or you may or may not have an organization identifier. You can add one. And if you add an organization identifier, it can be anything. It's usually a website that is reverse built, as mine would be. Instead of spacecoastwebhost.com, it's com.spacecoastwebhost, and the identifier appends the product name to it. It's going to be a SwiftUI. The language is going to be Swift, and none for the rest. And it's going to ask if you want to create a Git repository. We don't need it for this one, and we are going to create it. Okay, now that this is created, let's quickly go through what got built. You have your main root of everything, which is the name of the program, which is going to be In Between. Here's a project entry, In Between. You can have more than one project in your project files. Here's your assets, and where you're going to put your images and your pictures. And here, the In Between app is your entry point to the program. And the only thing to really notice here is if you see Content View, what that's going to do is it's going to call Content View here. There's your Content View. On the right is the preview, which gets called from right here. And basically it's just a globe and text that says Hello World. Now, the one thing to notice about this view is it is a struct. And a struct is different than a class. A struct is way more efficient. Is why SwiftUI likes to use structs. But struct is also known as what is called immutable. And what that means is once a variable is declared, it cannot be changed. So that's one thing to notice about a content view, or the view, is that it is a struct. So now let's take what we have learned and let's do the layout for this game. But before we go any further, I want you to download the assets. So you need to scroll down and find a link to the assets and double click on it, and it will get downloaded to your download directory. And when this zip file gets downloaded, you can double click on it, and it's going to make an uncompressed version called In Between. And I would like you to take all the assets that are in here. You hit Command A, and you're going to copy it into your assets directory. And what that's going to give you is it's going to give you your cards that we're going to play in the game. There's 52 cards plus one background. And then the other thing you need to do is you need to copy the audio player into the in-between project file. This is sound files that we are going to use, and it's going to tell you where you want to put it. We're going to copy it to the destination in between. When we say finish, there it is. So we now have the assets with all our cards, and we have a bunch of sound files that we're going to use to finish our game. On the right is a screenshot of what our final layout is going to look like. So let's go ahead and start building. First thing we're going to do is we're going to get rid of the hello world part. And the first thing we're going to need is the green background, which is going to be a Z stack. The Z stack is going to have an image as a background container. And if we go to our assets, it's going to be called green background. And let's see what that looks like. Now what we're going to do here is we're going to add a couple of modifiers to this. The first one is going to be, say that this image is resizable. What this allows you to do is it allows to make the image bigger or smaller than it needs to fit in this container. And the one last thing we're going to do is we're going to do what happens quite often in background images is this is called the safe area. This is where your power and the time and all that. And down here is called the safe area. We're going to ignore the safe area. And that is done by giving it the modifier called edges ignore safe area .all. And we got to get rid of the padding. So now we have the background in the Z stack. Everything else that's going to come in here is going to go right on top of the Z stack as a V stack because it's going to go top to bottom. And the first thing that we're going to add, if you look on the right, is up here. This is our logo, our in-between logo. And if you go to our assets, it's called in-between logo. The image must be resizable. So let's add the resizable modifier. And the other thing is we want to make it scale to fit. There's two different ways to do that. You can say scale to fit. What that's going to do is it's going to make the width fit in the phone, and then it's going to shrink the height to keep the same aspect ratio on the width. All right, now I'm going to add a spacer. Now what a spacer will do is take up all the space that's not being used and add it as padding. So for instance, if I wanted to move this in-between logo to the bottom, I would add a spacer to the top. But we want ours to the top, and it moves it to the top. And also I want to add a little bit of padding. I'm going to add padding to the top because it's approaching the safe area. So I'm going to say it's dot padding. I'm just going to say dot top. And if you don't give it a value, it's just going to be defaults. And I'm also going to give it padding to the bottom. What that's going to do is it's going to give us a little space right here between the cards and the let's play. So it's going to be padding dot bottom, and I'm going to go ahead and give it a value of 20. And now we're going to add some text. So the text is going to be let's play. And you see there's spacing right here. It's black, so we're going to add a foreground color of yellow to make it match. Give a predefined color, color.yellow. And we need to resize it, so I'm going to give it a dot font. There's many predefined fonts. And the easiest way to change the font size is to go ahead and type the dot and then just choose one you want. I'm going to choose large title. And there we have our let's play. We have our logo and our let's play. We're going to continue this method using V stacks, H stacks, and Z stacks until our layout is done. So now I want to add the 3 cards in the playing field. And the way the cards work are assets. The cards are numbered from 0 to 51 for the 52 cards. And card 52 is the background card. So I'm going to do 3 cards, image name 52, in an H stack to horizontally stack 3 background cards in order. So let's add an H stack. And we're going to have 3 images. And it's going to be 52. There's going to be 3 of those. And we want the H stack above the spacer. Otherwise, their space is going to be in the middle. So we're going to add it before the spacer. There's 1. We're going to do that 3 times within the H stack. I'm going to use Command C and Command V. There's 3 cards. We want these to be resizable. As this starts growing, they're going to have to be resized. And I want it to scale to fit. And I want that for all 3 of them. And the other thing we need to do is I want to put a spacer here, a spacer here, a spacer here, and a spacer here. As these cards grow and shrink, I want to make sure they're spaced evenly. So I'm going to add a spacer. And I'm going to do that between each card. And at the very end. Next, we have to do the images for the pot and for how much the player is betting. Now, this is going to be a little bit more trickier, but what it's going to be an H stack because it's horizontal, but it's also going to have a V stack. For the pot, it's going to have the image of the gold coins and how much money has been bet and is in the pot. And for the bet, it's going to have the image. It's going to have the amount of the bet, and we're going to have a slider here for you to make your bet. So, let's do it. So let's do a little outline of what we're going to do. This is going to be the bet layout right here. It's going to be an H stack. And the H stack is going to be for the pot and bet. And then we're going to have a V stack. And the V stack is going to have an image. We're going to call it pot image. And it's going to have the pot amount. And then we're going to have another V stack. And this is going to be the bet layout. The player bet layout. And it's going to have an image. It's going to have a bet image. It's going to have a bet amount. And it's going to have a slider. Let's move this over a little bit, give us a little bit more room. We're going to have an image. And it's going to be gold coins. And of course, we want it resizable and scale to fit. We're going to have a text field, or a text container is a better word for it. And it's going to say pot 0, and that's going to have a foreground color yellow, and it's going to have a font size, and it's default for me on dot headline. We're going to call it dot large title. All right, there's pot 0. Now for the V stack, for the bet layout, we're going to have the bet image. I want to copy this one and just change the name. I'm going to go ahead and copy the text too while I'm at it. So this is going to be called poker chips. It's going to be resizable, scale to fit. And the last thing we're going to have is a slider. I'm just going to add the slider as text. because there's a few things you have to know about the slider, but I don't want to get into it yet until we start writing code. So I'm going to say text slider, and let's give it a font and a color. And let's make it white, and the others are supposed to be white also. This is supposed to be white. And the pot is supposed to be white. Oh, this is supposed to be... Man, I think we're made it at 1. Let's go ahead and stick with what we see on the right. Bet 1. And this is supposed to be color.white. So there we go. It almost matches on the white other than the slider. So let's move on. So the next thing we need now is the start game. And the start game is rather interesting. It is 3 components inside a Z-stack. There's a white rounded rectangle, there's a red rounded rectangle, and there's text that says start game. And everything is embedded in a Z-stack, so everything is thrown on top of each other. Let's outline this a little bit. We're going to have a container for the game button. And what that's going to be is it's going to be a Z-stack. And then in the Z-stack, the first container is going to be a white. And it's called rounded rectangle. And what that is a rectangle with rounded corners. And the next component is going to be a red rounded rectangle. And then on top of those two is going to be some text. So the syntax for the rounded rectangle is rounded rectangle, and you give it a quarter radius. I'm going to move this a little bit to give us a little more space. Rounded rectangle, corner radius, we're going to give it 20. And we want to make it white, so we're going to give it a foreground color. It's going to be color.white. And now we're going to have another rounded rectangle. And we're going to give it a color of color.red. And we're going to have some text that says start game. And that's going to have a foreground color of color.white. And we're going to give it the same font we've been using, the large title. We want to add a bold tag to this. We're going to call this .bold and make it a little heavier. Now notice that you don't see the white rectangle. That's because you have 2 rectangles on top of each other. So what we need to do is for the red rectangle, we got to add some padding. And let's go ahead and add some padding. And we'll use the default for now. Now to use the default, I think that's a little bit too big. So what I'm going to do is we're going to add individual sizes. We're going to give it .top. We're going to make it 7. So now we just have padding on the top, and we want to do it all the way around. Padding.bottom 7. Padding.leading, we're going to call that 7. And trailing 7. That's the 4 types of padding. This button's a little big, so what I want to do is I want to put this inside a frame. A frame is a modifier that tells you how big you want it. Now with this font, I'm seeing 10 or 11 characters. They're going to be under 20 each. So for the width, I'm going to give it 250. And we're going to make the height a little bit bigger. Let's make it 75. And there's our button. So what we got left now is the player score. We got the player 1 and player 2 score, and we have the let's play text on the bottom. And I think what I would like to do is have you guys stop the video, try to implement this yourself. It is a great learning tool, And when you come back, I will show you how I implemented it. So let's go. So how did you do? If you got it, that is great. If you didn't, don't worry about it. This is a little tricky, but the more you do it, the better you'll get at it. So let me show you how I implemented it. The first thing I did is added a padding to the start game button. And for the player scores, I made it an H stack with 2 V stacks and a spacer in between each player and the edges. So to start off with, you make an H stack and then a spacer. The spacer is right here. And then there's a V stack, which will be the player 1 and his score. So the V stack has 2 text fields, player 1 and player 2. And since it's in a V stack, it's going to be on top of each other. Then there's another spacer. That's the space between player 1 and player 2. And that V stack has also 2 text fields, player 2 and 20. And then there's another spacer, which goes right here. Now, I also implemented it a different way. There's many ways to do this, but if you did it this way and it works, that's great. I implemented it as 2 separate H stacks. So the first H stack has a spacer, then text player 1, then a spacer and text player 2, and then another spacer. And then there's another H stack, and that H stack has spacer, text 20 for the score, a spacer, text 20 for the score, and a spacer. Now let's see how they look together. Okay, so here they are. There's both of them together. The top one uses an H stack with 2 V stacks, and the bottom one uses 2 H stacks. You can implement it either way. Now, for the Let's Play, that's very simple. Here's the spacer that we added at the beginning, but the text just says Let's Play. So to make sure you fully understand this, I want to go a little further into what's actually happening, maybe show some tips and tricks. But what I want you to notice is, look at the 3 cards on the board. When we added the player scoreboard and the Let's Play, the cards got smaller and the space between them got bigger. The reason for that is, as containers were added in the vertical direction, as more containers were added, each container got smaller. So as the cards container got smaller, the height of the card got smaller, and since the cards are scaled to fit, the width got smaller, so the space amount got bigger. And to show you how that actually works, I'm going to comment out the player's scoreboard, and as that container is removed, you'll see how the card container gets bigger and the width of the cards got bigger, so the space between them got smaller. So as we add the player scoreboard back, the cards get smaller and the space gets bigger. So what's happening now is spacing is probably ran out. So the other thing I want you to notice is that the H stack for the pot and the bet amounts are now running together. And the reason for that is the same reason. The container got smaller, so the images, the height got smaller, which means the width got smaller, which means each one is smaller, so they're now running into each other. Before, it took the whole width of the device, but now it no longer does that, and you have lots of space on the edges. To show you how you can see exactly what's going on, if you double click on the H stack that contains the pot and the bet amounts, you can give it a background color. So there's how big that H stack is. And that's because we don't have any spacers. Now, if we were to add a spacer in between the pot amount and the bet amount, this is now how that H stack gets allocated. For each of the V stacks, we're going to give it a background color so we can see exactly what it's doing. So the easiest way to do that for this V stack is you double click on the open bracket and it gives you the whole container for that V stack. And what we're going to do is we're going to add a background for that. And let's make it color dot blue. So that's the size of the V stack for the bet. And let's do the same thing for the pot amount. And let's make it purple. So we have the H stack, which is the whole width of the device. You have just enough to fill the gold coins and the text for the pot amount. Then there's a large space, and then there's the image for the poker chips, just enough space for the bet one and the slider. Now what we need to do is let's add a spacer to the beginning, and we want to add a spacer to the end, just like we did before. And now things are spaced correctly, but they still don't look right. So what I want to do is I want to change the padding a little bit for each one of those containers. So the poker chip one, I'm going to add a padding. For that image, I'm going to add a padding to the top. I want to bring that down a little bit. So that brought it down, and it even made it smaller. The other thing I want to do is I want to change the font for the bet. I'm going to make it something smaller. Let's do headline. That made the poker chip bigger. Now since we got the padding, it kind of fits in there better. And let's go ahead and change the font for the slider, because the slider is not going to be quite that big. We're going to make it dot headline also. So now you can see what's going on. So I like the way that looks. I'm going to get rid of the backgrounds. Let's format this a little nicer. So there we go. And there's one more little stickler that I need to show you. Now let's say we want to see what the background is for the Z stack for the button. There's the Z stack. So we're going to add a dot background. We're going to make it color dot red. And that's the way the Z stack looks with the padding. And the thing about it is the order really matters on this. If you were to put this background ahead of the padding won't be included. All you see is what's missing from the round corners. That's because the background gets set and then it gets padded, so you won't see that. So that's one thing that you'll pull your hair out with if you didn't know that. The spacing does matter when you want to give a background color for a container. So we're going to call that the finish for the board layout for our in-between game. If you like these videos, please help support my channel by subscribing to it, and you can be sure to never miss a new video. Welcome to part 2 of how to make a game with SwiftUI, where we are going to learn how to program in SwiftUI by building a game. In part 1, we built the user interface for it, so if you haven't watched part 1 yet, I suggest you do that now. And for now, what we're going to do is we're going to start actual coding, which is the fun part for it. So let's get started. For those of you new to Swift programming, SwiftUI uses a little different approach to keep the user interface updated. And here's an overview of it. It says use state as a single source of truth for a given value type that you store in a view hierarchy. Create a state value in an app, scene, or view by applying the app state attribute to a property declaration and providing an initial value. And below the example, it says SwiftUI manages the property storage. When the value changes, SwiftUI updates the parts of the view hierarchy that depend on the value. And what that means is anytime that state value is updated, SwiftUI automatically updates the user interface. So what I'm going to do is I'm going to use our Start Game button to implement this example. And what this example does, it's a play button, and the state variable is a Boolean. If the Boolean is true, that means it is playing, so the button will say pause, and you got to hit pause to make it stop playing. And if it is false, that means it's paused and you got to hit the play button and make it start playing. And anytime you hit that button, is playing gets toggled. And it's that toggling that writes to the state variable that makes the UI interface get updated. So let's make a button out of this start game. So to do that, we're going to say button. And here's the action. And the first action I want to do is I just want to print button pressed. And then this button itself is going to be in the label part of the button. And that's what you're going to see on the screen is what's in this label, which is our Z stack. Okay, let's go ahead and run it. So when I hit start game, you see button pressed. So now what I'm going to do is I'm going to create a state variable. And it's going to be a Boolean. And then I'm going to, in the action state of the button, I'm going to toggle game state. And then what that question mark means, if game state is true, then we're going to do this action. So if it's running, we want to hit pause to get it to stop. And then for the, if game state is false, there's the other part of it. We're going to hit play. Let's see what happens. So it looks like it's working. So that's working great, but a Boolean isn't really helping us any. It only gives us 2 states. So what I want to do is I want to change a little bit to give us 3 states. And let's see how that works. What I'm going to do is change this from a bool to an int. And we're going to start it off at 0. Okay, so down here, when you hit a button, it's not going to no longer be toggle. It's going to be increment. So we're going to say game state plus equals 1. And let's get rid of the text. I'm going to give us 3 states. State 0 is going to be start game. And once the game gets started, it's going to go to state 1, which is going to say player 1, deal. And then we're going to go to state 2, which is going to say where you make your bet and hit me. So we're going to call it hit me. So now to print out the text, I'm going to say if game state equals 0, we're going to print start game. So if game state is 0, if that's true, we're going to say start game. If it's false, we're going to do that again. If it's 1, we're going to say deal. If it's not 1, we're going to say hit me. And then up here where we do the increment, if game state greater than 2, we're going to set it back to 1. We're not going to go back to start game. We're going to go back to either player 1 deal again or player 2 deal again. I'm going to get rid of this print. Why did that text turn blue? But let's see what happens. Start game. Deal. Hit me. Deal. Hit me. So that works. So why is my font blue? Let me see. Text. Oh, I lost my foreground color. Let's add that back. And we're back to where we were. So things are starting to look better. Our buttons are working. We're getting the text changed. We're getting our game states working. But as you can see, it's getting a little bit hard to maintain now since we're having so many different texts on the button for the game states. Just 3 states by itself makes that text field look really, really ugly. We're going to have a lot more game states. We'll have player 1 win, player 2 win, ante up, game over, and it's going to start getting very hard to maintain. So what we're going to do is SwiftUI has a very powerful feature that's going to make our life much easier, and that's called enumeration. And we're going to make our game state an enumerator, and we'll see how much easier it is to maintain all this. An enumerator will make our code easier to maintain. It'll make it much more readable. It'll make it much more easier to test and a lot more flexible. And for those of you who've never used an enumerator before, it might look a little confusing at first, but it's very easy. And once this tutorial is over, you'll have a good handle on it. What we're going to do now is we're going to create a numerator that uses the enum keyword. We're going to call it game state. And the autocomplete almost got it. The first state is going to be start. The second state is going to be player 1 deal. And the next one is going to be player 1 hit me. And then it's going to go back to player 1 deal. Now, an enum is very customizable and very powerful, and what I want to do, the first thing I want to do is I want to be able to print out GameState.description. And what that's going to do, if we're like in the start stage, it's going to print out start game. All right, this game state is going to be an int to begin with. And the way we make it where you can print out a description is we're going to let it conform to the custom string convertible. And what that is, custom string convertible, what that allows you to do is define a description string, and you could call it from anywhere on any one of the enums. So in our enum, see, it's complaining, it's saying the game state does not conform to this protocol, but it's very easy. All we have to do is say var description string, and our autocomplete got very close. It's not going to be start, it's going to be start game. It's going to be not player 1 deal, it's going to be deal, and it's going to be hit me. So we're going to go from start game to deal to hit me. So down here at the bottom, where we print out the text, it's just going to be GameState.description. No matter what state we're in, the enum will resolve it. .description. Now, we got one more thing we got to do. You can't directly assign an integer to a type of game state. And it says 0. I still got to make my game state. It's now a type of enum of type game state. And it's going to be .start. And there we have start game. So that's working. Now the only other thing we have to do now is, since we can't directly assign an integer to our enum, we got to give it one more type, and that's called case iterable. And what that does is allows you to make a collection of all the cases and iterate through it. For instance, you can use a for each. You could say, for instance, for each state in game state, and iterate through all the states. And so what we're going to do is we're going to use that iteration protocol, the case iterable, and that's just a gimme. And we're going to create a next for it. All right, we're going to say var next. It's going to be of type game state. And I'm going to say let all cases equal game state.cases, and the auto completion did a pretty good job. Let me see. All cases equals game state.all cases. What that's going to do is all cases is now going to have a collection of all our cases in our enum, which will be 3. And then it's going to say current index. It's going to be the first index in all cases of self, which is the current game state. So if it's start, the first index will be 0. If it's player 1 deal, the first index will be 1. And then we're going to increment the index, and we're going to use a mod function to see if there's a remainder. Otherwise, it'll go back to 0, so it won't go past the end. So it goes 0, 1, 2. When it hits 3, it's going to go back to 0. And I got a problem here. That's why I was having trouble, is I'm inside the description. It needs to go right here. Now, when you click on the button, we're just going to say GameState.next. Game state equals so let's see what we get. Deal, hit me, and went back to start game. Okay, we're going to step through the next so you fully understand what's going on here. All right, we're going to hit start game. All right, let's single step through this and let's see what happens. All cases, there's 3 values. We know that. We have start, player 1 deal, and hit me. So we now have a collection of 3 enums, 3 cases of in the enum. And then we're going to see what the current index is. Of course, the current index is 0. It's 0. We're going to increment it. And now we're going to return a type of game state, which will be all cases sub 1. That's a game state of player 1 deal. And it went to deal. And then when let's do it one more time. The next index is going to be, your 1 is going to be 2, so it's going to be player 1 hit me. And then it's going to roll around back to what's going to happen here, the modular of count, which is 3. So when it goes to 3, the remainder is 0, so next index will become 0. That's what this mod function does here. It returns the remainder. So if it's a 1, 1 mod 3 is 1 divided by 3 with 1 left over, it becomes 1. 2 mod 3 is 2 divided by 3, which is 0 with 2 left over. 3 divided by 3 is 1 with 0 left over, so next index becomes 0. And let's see what next index is. Next index becomes 0 because of that mod function. So that's, make sure we don't go past the end, but what we don't want is we don't want to go back to start game. So one thing we have to do, we say game state equals game state.next. I'm going to say, after it's already been done and we hit the button, I'm going to say game state equals dot start game state equals dot player one deal. So we're already in when we hit this button. So we've already hit it once. So we'll never go back to start again. Let's redo this. All right, so let's run it. Start game. Deal. Hit me. And back to deal again. Exactly what we want. Next, we're going to add some sound. Now, SwiftUI makes it extremely easy to add sound to your project. There's a framework called AV Foundation, which pretty much makes it very, very simple to do this. So you're going to import AV Foundation. And what you're going to do is you're going to create a player. You're going to create an AV Foundation audio player called AV Audio Player, and it's a conditional because it may or may not be instantiated yet, so it may be null. And we're going to go down to the bottom of our code, and we're going to create a function called play sound. And you'll see it's basically with 3 lines of code you can play an audio file. So play sound is going to pass in a file name, and that's of type string. And the first thing you want to do is you want to take that file name and convert it to a URL. So we're going to say if let file URL. What that's going to do is it's going to create a URL on the bundle.main.url for resource. What that's going to do is it's going to use your resource that's already in your project to load this file. It's going to be an MP3. All our files are MP3. Now, if that fails, we're going to print error loading audio file. MP3. And now this loading this audio file may cause an exception, so we're going to put this in a do catch statement. And what that's going to do is if for some reason this is going to cause something to crash, this catch statement will catch it, and it won't make your program crash, which is gracefully handling this error exception. And then what we're going to say is we're going to say player, player equals and I'm going to put one in between here. It's not necessary, but I like doing it. And it's called prepare to play. Okay, and that's basically all there is to it. Clean it up a little bit. And there's your audio player. Now let's use our friend, the game state enum, to tie all our audio files to the game button. Let me change this to a capital S. That's called camel case. That's the way I like to do my functions. And like I said, this prepare to play, it's really, you don't have to because play calls it, but in certain cases, I'll set up everything and then call prepare to play and then later call play. So I always like doing that, but it's not necessary. So let's go to our enum. And we're going to add a variable called audio file, which is a string. And once again, the auto correction, auto completion worked pretty good, except for it should be the same file name as what we see over here in our audio player folder. So it should be let's play player one deal. and it is case sensitive. It has to match. And then player one bet, which is actually player one bet hit me. Okay, there we go. All we got left to do now is when you hit the button, you're going to call play sound, file name, and it's going to be game state dot audio file, and let's run that and see what happens.
Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
So it looks like it's working. What we didn't get was the let's play. And that's because when you hit the button, we go to deal, you don't ever hit a button and go back to start game. So what we're going to do, when this Z stack gets loaded, I double clicked on the Z stack to see the bottom, you can call on appear. And what we're going to do is we're going to play sound, and we're going to play let's play. So let's run it, and we'll see that we're going to hear let's play when the whole thing gets loaded.
Let's play.
All right, so that finishes that. So now that we got everything in place, our framework is done. We got sound. We've got it modularized using our enums. In the next video, we're going to go ahead and implement a complete one-player game. And once that's completed, we will move on to make it a two-player game to play against the computer. Want to learn a language? Language Book Reader from the App Store teaches languages from arguably the best resources available. All the language courses were developed by the government and are public domain, making them the best and cheapest courses available. People used to ask, how do government officials learn a language so fast and efficiently? The answer is simple. They use these courses. In this video, we're going to implement the functionality of the game. We're going to develop the framework. So, without further ado, let's get started. We are now ready to start implementing the game. And what we're going to do at first is we're going to only implement player one to play. And so what player one's going to do is going to get some money, and the pot's going to get some money. And the goal of the game is for player one to get all the pot's money or the house's money. And if the house gets all the player one's money, then the house wins. If player one gets all the house money, then player one wins. So we are going to implement a start game, a deal, a bet, and a game over. So let's get started. The first thing we're going to do is comment out player two, make it a one-player game. So we're down to player one, and then where the button gets pressed, I want to make that into a function. Called process button. So we're going to make a function called process button. And then what I'm going to do is I'm going to do a switch statement. first one is case dot start. And it's going to be what we've already done. It's just going to change the state to player one deal. All right, it's complaining because it's not exhaustive, so we have to make it exhaustive. All right, there's the switch. So what we're going to do is we're going to give it a default case, and we're just going to hit break. All right, so that should get us where we are. Now we're going to do a case dot player one deal, and we're going to say get board cards board and create a function get board cards, and we're going to make 3 cards. And so what we're going to do is where we print the cards, right now we're just hard coding the 52 because that's the image for a background. So what we're going to do is we're going to create 3 cards. It's going to be of type int. And we want 3 of those. So we got card 1, card 2, and card 3. Card 1 is going to be the first card, card 2 is going to be the last card, and card 3 is going to be the hit me card. Right now they're going to all be 52. And they need to be a state, because when the card changes, we want to redraw. And now we'll redo the cards. We're going to make a string of int. Oh, it's complaining. What'd I do? Get board cards. Did I spell it wrong? Get board cards. There we go. Now we're going to make, where we do the cards, we're going to make it an int. So we're going to do string interpolation is what it's called, and we're going to put card 1, which is going to be 52. And then we're going to do card 3, which right now is 52. And then this one's going to be card 1. I'm sorry, card 2, which is 52. What's my syntax error? Oh, right here. Now when we change the card, it will get updated to reflect it. For instance, let's make card, oh, that's why I don't line up. These need to be private. That needs to be private. Let's make card 151. It's going to be an ace. There we go. But for right now, we're going to make it 52. So now we have it where we can change what the card is when we deal. And so for get board cards, we're going to get a random number for the cards. So what we're going to do is we're going to assign card 1 to a random number. 1 and 52. We're going to make this, we're not going to hard code this. Let's call the first one first card. We'll call the last one last card. Hard coding numbers is typically a bad practice. So we're going to say let first card equals 1. Let last card int 52. All right, now let's go back down there. We're gonna say card 2. It's gonna be the same thing. Now this could be a problem because card 1 could be the same card as card 2, but we'll deal with that here in a minute. And card 3 is gonna be 52 because when you first deal, it's gonna be turned over. So we don't know what it is before we make our bet. And let's see if that's all we need to do. Let's run it. Start game.
Player 1.
Oh,
Deal the cards.
it dealt too soon. I see what happened. I should not have incremented the game state here. I should have done it in the case statement. So what happened is the game state is start, so when I hit the button, I want to process it right here. But what I did is I incremented game state, so I'm no longer in start, I'm in player 1 deal, and so it deals. So we're not going to increment it here. We're going to increment start. It's going to go to player 1 start. Then when we hit it again, it's going to go ahead and deal, and actually right here, I'm going to go to the next state. I'm going to say .next, which won't do anything, because it'll go to this default and it'll just break. Oh, game state equals game state.next. So let's see what happens now. Okay, hit start game.
Player 1. Deal the cards.
And then we're going to deal.
Player 1. Make your bet and hit me.
Okay, so that works. We got the deal working. Now we have to work on the hit me. Okay, now to do the hit me portion of it. Basically, the hit me portion of it is the meat of the whole game. It's going to determine whether the player wins or whether the game is over. So what we need to do is we need to make the pot amount, the bet amount, and the player 1 amount variables. So what we're going to do is we're going to go to the top. We're going to add 3 state variables. It's going to be at state, private var, player 1 score, and we're going to start off with it being 20 at state, private var pot amount, and that's going to be int 20, and then we're going to have the bet. Now the bet is going to be tied, I'm missing the var keyword, so the bet is going to be tied to the slider, which we're going to do next, and the slider wants it to be a double. So we're going to have to say bet colon double. And we're going to make it default always to 1. Okay, now what we need to do is we need to update where we're writing out these variables. Pot amount, we're going to use the string interpolator. So it's going to go pot amount. Okay, that got resolved. And then next thing, the bet is going to string interpolate it, but we have to typecast it to an int because it's a double and we want it to be an integer. And that got resolved. And now we have to do the slider. So we no longer want this text, we want an actual slider. And the syntax for the slider is slider, and it's value, and it's going to go in from 1 to double pot amount. The reason there's a $1 in front of that bet, that means it's binding. And what that's going to do is the slider is going to bind with the variable that we just declared called bet. So when the slider moves, it's going to have a value. It's going to keep that bet in sync with that value. So if the slider value is 10, if you look at bet, it's going to be 10. So if you change the slider, the bet will change. You could also in code change the bet. You change the bet to 20, the slider will actually move. So what that $1 bet does is it makes it binding and bet stays in sync with the slider. So notice how when you move the slider, the bet amount changes. I think the slider is a little too big right now. Let's add some padding, and I'm going to call it dot horizontal. Let's do 25. That's a little better. So here's our slider, and it's changing the bet. That means they're binding, and they're both in sync. Let's do the logic to see if player 1 won when you hit me. So what I'm going to do is I'm going to create a function called didWin. And the first thing we got to do is we got to see what card 3 is, because right now it's the backside of a card, so it's 52. So what we're going to do is we're going to do the same logic we used when we made a card. We're going to say card 3 is going to be that. So card 3 is going to be a random of first card to last card. And we don't want card 3 to equal card 1 or card 2. So what we're going to do is we're going to say while card 1 equals card 3, or card 2 equals card 3. We're going to do this again. So now we know card 3 does not equal card 1 or card 2. So now what we want to do is we want to convert the card. Instead of being a card between 0 and 51, we want to make it a card between 2 and 15. That way we're just comparing 2s to 2s and 3s to 3s instead of 2 of hearts to 2 of spades. So how we're going to do that is we're going to say let int card 1 equal card 1 divided by 4 plus 2. So if card 1 is a 0, 0 divided by 4 is 0, 0 plus 2, it'll give it a numeric value of 2. We want to do that for all 3 of them. If card 1 is a 0, 0 divided by 4 plus 2 is 2. If card 1 is a 1, 1 divided by 4 is 0 plus 2 is 2. Or if it's a 3, if card 2 is a 3, 3 divided by 4 is 0 plus 2 is 2. And if it is a 4, 4 divided by 4 is 1 plus 2 is 3. So 0, 1, 2, and 3 will be a 0, will be a 2. 4, 5, 6, 7 will be a 3, and that's correct. That's what we have in our assets folder. So 0 through 3 is a 2, and 4 through 7 is a 3. All right, I just realized I've got a mistake here. I don't want to compare card 2 to card 1. I just want to make sure card 1 and card 3 aren't the same, and card 2 and card 3 aren't the same. Okay, so now that we got that done, we want to check to see if we're a winner or not. And the way we're going to do that is we're going to first check to see if int card 1 is greater than int card 2. That would mean that the left first card is going to, let's say it's a king, and the second card is a 2. That means card 3 in the middle has to be less than card 1 and greater than card 2. So we're going to say and. So we're going to say and int card 3 is less than card 1 and int card 3 is greater than int card 2. Or the other one is card 1 is less than card 2. So if that's the case, then we need card 3 to be greater than card 1, and we need card 3 to be less than card 2. All right, so we want int card 3 to be greater than card 1 and int card 3 to be less than int card 2. And if that's the case, we have a winner. For now, let's just say print you won, else you lost. Okay. Oh, I forgot to do this check right here. Down here. So let's bracket this off. And then we need that check, but it's the opposite. Int card 1 is greater than int card 2 and the rest of that. Oh, int card 1 is going to be less than int card 2. That means card 2 is the king this time and card 1's the 2. Now what we need to do is we need to add our state here. And when we hit case player hit me, we're going to call did win. We're going to let did win set the next state. It'll either go back to deal, either you won or you lost. It'll go to game over. So if you won, the pot amount plus equals int of bet and player 1 score minus equals int otherwise. Otherwise, just the opposite happens. And for the sake of the next test, we're going to assume game wasn't over. So game state equals game state dot deal. Player 1 deal. Game state dot player 1 deal. Oh, wait a minute, I got that backwards. If you win, the pot gets decremented and the score gets incremented. And if you lost, the pot gets incremented and the score gets decremented. All right, let's see how it works.
Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
I lost. It didn't get decremented. All right, we're going to see why player 1 isn't updating. So where are we printing out the score for player 1? Player 1, we're just printing 20. So let's do a string interpolation. And we're going to say player 1 score. Let's try that again.
Player 1. Deal the cards. Player 1. Make your bet and hit me.
That didn't work. So why was card 1 the back card, which means it was 52? Let's see where we... last card is 51. So it got itself a 52. All right, let's try it one more time.
Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1.
18.
Deal the cards.
That's good.
Player
6
1.
and a jack.
Make your bet and
Okay.
hit me.
Now what you may have noticed is that when I first start up the app, you don't hear Let's Play. That is because every time it gets initialized, I hear that and it drove me nuts. So I commented out here. You may be hearing it. You're not hearing it on me because mine's commented out. I will uncomment it when the final one is finished. Okay, a couple little minor points. Did win. If you won, I want to play sound file name, and it's going to be TADA. And then if you lost, I want to play sound you lost. And one other thing, when we do the cards, I got to do one of these on the board that we never did. I know I mentioned it. Get board cards. We can't let card 1 equal card 2. Well, card 1 equals card 2. And we're going to just keep doing card 2 till they don't match. Okay, I think the only other thing we got to do now is we got to check for winner. But first, let's run it and let's see what we got.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
So we didn't hear the you lost sound. And let me show you why. So right here, where we did win, it was going to play the sound that we lost. So it did play sound. But the audio player is what's known as asynchronous. What that means is it'll play the sound and then just keep going and running the code. So right in here where we called did win and played the sound, it immediately returned and came down here and played the sound, which was deal the cards. So what happened is before the sound to say you lost got to play, deal the cards overrode it. So what I'm going to do, let's do this. I'm not going to play that here anymore. I'm going to play that over here in each state. So when you hit the start button, we're going to increment to deal, and you're going to play the sound that says deal. When you hit the deal button, we're going to get the board cards. It's going to increment the game state, and then it's going to play the sound for hit me. And now did win, when it plays, all it's going to do is play whether you win or lose, and you're not going to hear the deal the cards because it's not going to play that sound. So the did win is actually going to have to play two sounds. It's going to have to do the sound whether you won or lost, and it's going to have to pause and wait a little bit, and then it's going to say deal the cards or game over, depending on where we're at. So let's do it, and let's see what happens.
Player 1. Deal the cards. Player 1. Make your bet and hit me.
So you lost, you heard that sound. So what was happening is it was playing the sound, but before it got a chance to play it, it was dropping down here and playing the deal sound. So let's work on delaying the deal card sound after we do the win or loss sound using a timer. All right, so we're going to finish up the final functionality of this by adding the check to see if the player did win. The first thing we're going to do is we're going to add a timer. And the way you do that is you say let timer equal timer dot publish every, we're going to say 0.2, that's going to be 5 times a second, on main in. We're going to call it .common. And we're going to auto connect. Okay, so there's our timer. And now we're going to add an event to our timer. Well, it's 0.2. Okay, now we're going to add an event. We're going to add it right after the onAppear. Now the onAppear event happens every time we have it on the Z-stack. Every time the Z-stack loads, we're going to have an onTimer event, onReceive event, and we're going to give it the timer that we just declared. And then it's going to pass in onReceive timer. Okay, now we're going to add a function called check for when. Here's did when. We're going to add it right here. That's going to do. We're going to say if pot amount equals 0. That means player 1 won, because he got all the pot's money, all the house money. And what we're going to do, so that means player wins. And what we're going to do is we're going to delay playing the player wins game sound. And we're going to set the game state to game over. Else if pot amount equals 40, that means player loss. So we're going to delay playing lost game sound. I see I forgot to put delay playing the player one game sound. That's what I wanted to do, lost game sound. And we're going to set game state to game over. Else the game is still going. Set delay deal cards. And we're going to set game state to, in this case, player one deal. Else if. Oh, this construction's all wrong. So it's going to go else if and then it's just going to be else. Okay, that's correct, except for that. Okay, that's the way it should look. So what we're going to do, we're going to have to delay the player one sound. So what I'm going to do, I'm going to set three variables. One to delay playing deal cards, one to delay playing player one wins, and one to delay playing player one loses. So we're going to have right now, where we're doing our variables. So we're going to have to make it a state variable. Actually, I'm going to put it outside the structure because we're going to move it when we refactor this. So I want it up here so it doesn't have to be a state variable. So I'm going to say var delay deal cards equal deal cards. It's going to be an int, and it's going to equal 0. And that's going to be a countdown timer And when the timer counts down, it's going to do the function that it needs. I'm going to say delay playing, player wins. That's going to be an int 0, and delay playing, player loses, int equals 0. So now we have our placeholders. Once we have all this in place, it gets surprisingly easy. What we're going to do is we're going to go down to our timer event, and we're going to use those variables as a countdown timer, and when they get to 0, we're going to fire the event. So we're going to say if delay deal cards is greater than 0, we're going to decrement it, delay deal cards minus equal 1, and if delay deal cards equals 0, we're going to fire the event. And we're going to do that for all 3 of them. We're going to do delay playing, player wins. And we'll decrement it. And if it's 0, we're going to fire the event. And we're going to do the same one for player loses. Okay, now we're going to go down to check for win, and we're going to go ahead and do the delay card. So what we're going to do is we're going to say delay deal cards. Now it gets fired every 0.2 seconds, so it's going to be 5 times a second. So if we set it to 5, that'll be 1 second. We want it to do 5 seconds, so we're going to set it to 25. And then the last thing we need to do is in did win, instead of calling this, instead of setting the state here, we're going to check for win. And now we're going to go up to the timer, and we're going to actually put what we want the event to fire. So we want to fire the event for deal cards. That's going to be play sound. And that's going to be, I believe it's player 1 deal. Player 1, let's see, it's player 1 deal. And we're going to set the game state equals game state dot player 1 deal, and that should be very close to what we need to do. Actually, it's capital P player 1 deal. And let's add the states. So let's add a case for player 1 wins, player 1 loses, and I'm going to go ahead and add a case for game over. I don't know if we're going to need it or not. And let's go ahead and add the descriptions. Case dot player 1 wins, player 1 loses, and game over. We're going to return game over. In the audio file. We're going to add a default to cover all the cases. And we're going to just return an empty string so it won't play anything because we're going to be playing that in the check when. And in the check for when, we're going to add delay. Player 1 wins equals 25. We allow the player score to go negative, so what we're going to say is if player 1 score, and then we're going to play delay, player 1 loses equals 25. And we also need to set the game state. We're not going to set it to game over. We're going to set it to player 1 wins. So game state. And then we're going to also set it to game state to player 1 loses. Process button. We're going to add a case statement for player 1 wins. Player 1 loses, and game over. We're going to set the variables back to what they were when they started, so we're going to add initialize new game. So let's add a function. Initialize new game. We're going to make player 1 score is going to equal 20. Let's get rid of all these. We're going to make the bet amount 1. Equal 52. We're going to make card 2 equal 52. We're going to make card 3 equal 52. We're going to get to set the game state dot start, and then we're going to play the sound. It's bet. And we need to add the pot amount to 20. The other thing we didn't do is we never set the status. It always says let's play, so let's go ahead and add that now. So what we're going to do is we're going to go add another associated property for status, var status text 1. It's going to be a string, and we're going to see what they say. So start is going to say let's play. Player 1 deal is going to be player 1 deal the cards. Player 1 hit me. It's going to be player 1 hit me. Let's put a space in between player and 1. Player 1 hit me. Player 1 win. You win. I like them uppercase. Player 1 loses. Say you. This is going to be player 1 you win. This is going to be player 1, you lose. And we're going to add a default so we have all the cases covered. And we're going to return let's play. And then we're going to do the same thing for status text 2. The only thing that's different here, it should be a player. Everything look good because I'm going to copy and paste this. That's going to be status text 2, and the only thing different is going to say status text 1 is going to say hit me, and status text 2 is going to say make your bed. And now we need to change where we say let's play. We need to change that to use our enum. So that's going to be GameState.statusText1, and at the very bottom we say let's play GameState.statusText2. So now let's run it and see what we got.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. You lose. Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me.
So with that, we're going to call it a wrap. In this next video, we are going to spice up this application by adding some animation. If you like these videos, please help support my channel by subscribing to it, and you can be sure to never miss a new video. Welcome back, everybody. This is Randy from Programmer Zen for part 4. How to make a game using SwiftUI. If you got it this far, I'm hoping that you're very happy and proud with yourself for making a fully functional game that you can show off and make changes and use it as a foundation to make more games. But to be quite honest, if you were to show this to somebody that what you did, like an employer, you probably wouldn't get the job because it's missing the most important part of programming, which is called data abstraction. And what I'm going to show you is a design pattern that you need to learn, and this is probably one of the most important topics of this whole course. It doesn't really apply just to SwiftUI. It applies to any programming. I'm going to show you a design pattern. There's many different design patterns. There's a very popular one called MVC. I am going to show you MVVM, and it's a way to modularize and abstract your data to make it more readable, more usable, and more maintainable. This diagram briefly outlines the architecture of the MVVM, which stands for Model View View Model. And what it does is it breaks out the data and the logic behind updating the view into the view model. So the view basically just has all the view presentation logic. The view model has all the functionality to perform the logic to update the view. And the model contains the data abstraction. And in our case, it's going to be the game state enumerator. So what the view does is it creates a state object of type view model. So in our code, we're going to say, in our content view, we're going to say state object var content view ViewModel, which will instantiate a ViewModel. And what we're going to do is we're going to take all our state variables and we're going to make them publish variables. And we're going to take all the logic we use to update the view, such as when the button was pushed or we were dealing the cards. We're going to move that to the view model, and then we're going to update it so the view can use the view model to gather the data. And by making the content view state object, the view model will automatically notify the view anytime a published variable gets updated, much like it did as the state variables got updated in our view. Any view that creates a state object from our content view view model now becomes observable, so any view that has that state object will be notified when the view model updates. And let's get started. So the first thing we're going to do is we're going to create our folders for each group. So we're going to say new folder. The first one's going to be models. And then we're going to create another folder for the views. And we're going to create another one for the view models. And the first thing we're going to do is we're going to put content view into the views. And we're going to create a model. So we're going to do new file from template. It's going to be a Swift file. And we're going to call it content view. And this is a popular naming convention. You do the content view is our view, and then we're going to say models, model, content view model. And then we're going to create a view model for content view. So it's going to be new file from template. It's going to be a Swift file. And it's going to be content view view model. Now the first thing I want to do is I'm going to move play sound into its own class in audio player. So what we're going to do is we're going to create a new file. It's going to be a Swift file. And we're going to call it audio player. So we're going to move all the play sound stuff to the new audio class. So we need the AV Foundation import and the audio player. We're going to remove it from there. We're going to add it here. Now we're going to create a class, audio player, and we're going to put the audio player function in there. Now this audio player no longer needs to be global, because if we put it in a class, it's no longer immutable. So we can assign a sound file to it. And then in content view, we are going to say private var player, and now wherever we're going to play a sound, it's going to be player dot play sound, and here's going to be player dot play sound. Player dot play sound. I'm going to start cutting and pasting these. Player. Okay, so what we did there is we created a class called Audio Player. We imported the AV Foundation, and we created a player variable inside the class. And since the class is not immutable, where we say player equals, it won't complain. Now, if this was a struct, as we had before, it's going to complain. Can't assign the property self is immutable. But now that it's in a class, we can do that. And now, instead of calling the play sound function we had in content view, we are going to call the variable player from audio player and call the function play sound. Now we're going to move our enum data structure to the models folder. Now we're going to move all our variables to our view model. And let's create a class. It's going to be content view view model. Paste in the variables, and we have a couple global ones I want to move over. These are not going to be published. Now, all the state variables that need to be a state variable are going to get changed to published. The timer needs to stay in the content view because the timer is tied to a view. Now we're going to copy all the functions over. So in the content view now, we have to create the class for our view model. So we're going to say at state object. Oh, it needs to be an observable object. I forgot to do that. Okay, and the next thing I want to do is I want to copy the events over. So I'm going to make an onAppear event. So it's going to be view model onAppear. And I want to make an onTimer function. that's going to be ViewModel on timer. All right, now let's take a look at our content view ViewModel. Oh, I got that spelled wrong, don't I? Let me fix that. All right, let's take a look at it. Now what we have is a bunch of private variables brought over from our content view, and they're going to stay private all except for this bet. Now the bet can't be private because it needs to be used in the view using the slider so the view can make the bet. So he's not going to be private, the view's going to have access to him, but the rest of these are going to be private, including these. And you might say, well, if these variables are private, how's the view going to be able to access them? So how are we going to be able to deal a card or show the player's score? And the answer to that is we're going to have what's called wrapper functions. And what a wrapper function is, it's a function that's going to return a value of what you're looking for. So we're going to have some wrapper functions. For instance, when you need the string for card 1, we're going to return a string in our wrapper function that's going to return string card 1. And since this is so small, I'm going to put everything on one line. So there's card 1. Now let's go out to the content view. And where we're using card 1, it's now going to be ViewModel, which returns a string, card 1. I don't think you need that, do you? Yes, you don't need print. So we're going to do that for the rest of them. We're going to do card 2 and card 3. We're also going to do it for pot amount. Which is going to return player 1 score. And we're also going to have the status text from game state. Which is a string returning game state status 1 text. And then we have that for status 2 text. Which returns the game state, associated variables, status 2 text. And then we got one more for description, which is the button. Now let's go back to our content view and let's use all our wrapper functions. So the status text 1 is now going to become ViewModel status text 1. Why did it have to be used there? I guess you do have to use. I thought I was going to let us get away with it, but I guess not. This one's going to be ViewModel card 3. The middle one's card 3. This one's going to be ViewModel card 2. This one's going to be ViewModel pot amount. This one's going to be ViewModel.bet. Now, bet has access directly to it. That's not a wrapper function because bet is used in both the ViewModel and the view, so it's not going to be a private variable. So there it is there. Now this is going to be ViewModel.bet as a binding object. And this is going to be ViewModel.potAmount again. And that's going to be ViewModel process button. This is going to be ViewModel.description. This is going to be ViewModel Player 1 score. This is going to be ViewModel Status Text 2. ViewModel Status Text 2. Let's run it.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me.
So it works. Why use MVVM? For those of you new to MVVM, it might not be immediately clear why MVVM is so important. Let's assume you are working with a team developing in between. You probably will have a graphics department that will work on the presentation or what the user sees. This is the view. You probably will have some software developers that will work on the functions of the app. This is what is in the view model. Then there are the database developers. They work on the actual data which is represented by the models. If all three groups are working on content view.swift, then there will be three different versions of the file when all three groups are finished. Furthermore, each group might be using Git repositories and have multiple versions of the content view checked out, which eventually needs merging. If all the groups use the same file, this becomes a nightmare when it's all done. A full discussion of MVVM would need an entire video, but this will touch on some of the benefits. The relationship between the view model and the model is similar to the view model relationship. The view is unaware of the implementation of the view model. All it cares about is when rendering the game button, it gets the proper description for the current state. It's unaware that it's implemented using an enum. The model can change the data design and use a database to store all the game data. The less changes that the view model needs to make, the more what is known as loosely coupled the implementation is. To better understand the concept of lightly coupled and loosely coupled, let's take a look at the two variables in the view model. Let's look at bet and status text 1. Status text 1 is a private variable and is accessed through the view through a wrapper function. If a programmer changes the variable name status text 1 to something else, he only needs to update the wrapper function to reflect the change, and no modifications need to be done in the content view file. If the programmer changes the bet name to say something like bet amount, since it is directly accessed by the view content file, a change needs to be made. So we can say that bet is tightly coupled and status text 1 is loosely coupled. One must strive to make the software implementation as loosely coupled as possible. MVVM is a great tool to simplify this process. So it looks like everything is working, so this is completely done. There is still one more part left to this video, and it's a must for anybody developing any apps for the App Store. It is going to involve animation, and it's very, very important because an app looks very bad and won't go anywhere without spicing up with some animation. Looking forward to the next video. Until then, enjoy your gaming. If you like these videos, please help support my channel by subscribing to it, and you can be sure to never miss a new video. Video series, we're going to add some animation and basically just make this app look a lot more bouncier and spicier and just look better. We're not really going to change the functionality at all. We're going to add some animation. We're going to add a few things to it. Let's take a look at it and see what the changes are.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
When the app first starts, the dealer scales into view, and then that is called a transition. And in SwiftUI, a scale transition animates the insertion or removal of a view by changing its size. And this example is a very good example of it. So what it does is it creates a state variable called show circle. And then it has a button which toggles the show circle, but it toggles it with animation. In order for the animation to work, you have to add the dot transition line with the transition type of dot scale. And that's really all there is to it. So when you click on the button and the circle comes into view, the default for a transition scaling going into view is coming from smaller to bigger. And it'll transition in it just like it transitions the dealer coming in. When a view is removed, the transition defaults from bigger to smaller. So let's try it. Let's, according to this example, and let's see how it works. So what I'm going to do is I'm going to create some publish variables that'll zoom a view in and out, and one of them's going to be the card view, and one of them is going to be, I'm going to call it the board view, which is going to be the dealer coming in and out. So I'm going to say app published, private var, show board view, and that's going to be bool false. That's going to be whether the dealer image zooms in and out. And I'm going to be show card view. Now the board view is going to have multiple images. At the end of the game, we're going to zoom in and out a winner image or a loser image. So I'm going to give another publish variable, private var, and it's going to be board image. And to begin with, it's going to be what the dealer's image is, and that image is in between board 2. That's just board image. And now we got to make these wrapper functions so they can be accessed in the content view. That's going to be func show board view. It's going to be a bool. It's going to be show board view. It's going to be a bool. And it's going to return show board view. And then this one's going to be, that's going to be the same as this one, but it's going to be card instead of board. And board image is just going to return a string. Board image. Okay, there is our wrapper functions. So I'm going to go to the content view, and we're going to add a show card view, which is going to be right here in this H stack. We're going to say if show card view, and this is what's going to animate it in and out. So we're going to say if show board view, and we're going to have an image. This image is what's going to toggle in and out. It's going to be board image, and it's going to be resizable. We're going to scale to fit, And we're going to add the transition. And it's going to be scale. Opacity is another one, but this one's going to be scale. And this should be ViewModel dot showboard view. This should be ViewModel dot board image. And this should be ViewModel dot show card view. And we're going to wrap this all in a Z stack because the cards in the dealer are going to share the same container. Okay, so back in the content view, on Ante here, we're going to initialize the game. Initialize new game. And in there, we're going to do the with animation. We're going to transition the board view. And initialize new game, I'm going to say with animation. I'm going to say show board view equals true. And basically, that's going to give us our animation. With animation, we have to import SwiftUI. I bet we're not doing that here. No, we're not. We have to import SwiftUI. Import SwiftUI. All right, let's run it and see what we got.
Let's play.
All right, I noticed a couple things. Let's address them now. The first thing I noticed is a dealer, he zoomed in real fast. So we're going to set a delay amount for how long it takes for that transition to happen in our with animation. Add a duration, you do that by saying ease in and out, duration, and let's give it 2 seconds. All right, let's see what that does. All right, that looks much better.
Let's play.
One other thing to notice is that when the dealer zoomed in, everything got resized. And the reason for that is we didn't have a view until he became active. And when he became active, everything got resized. So to prevent that, I'm going to do a little trick here. We're going to have a card view visible. And the way I'm going to do that is I'm going to add one more card. Called no card. It's going to be an int. And it's going to be 53. So the card will be there, but there is no image with 53. And down in initialize new game, instead of making it 52, I'm going to make it no card. So it's going to put it in the container. So it won't resize it when the dealer comes into view, but you won't see the card. So let's see what that does. Let's see if it fixes the resize. Much better. Okay.
Let's play.
That part's done. So the next thing I want to do is I want to animate dealing the cards. So what I'm going to do is I'm going to create a variable called dealing cards. And what that's going to do is every time you enter the timer loop, it's going to display a different bitmap to mimic animation. And also, we've got multiple cards, so we're going to have a variable telling us which card is being dealt. And to begin with, it's going to be 1 for the first card. The first time you're going to see this bitmap, and it's going to animate. It's going to start moving the hands, it's going to grab the card, it's going to try to deal it, it's going to deal it, and then it's going to be done, and then the card's going to be dealt. So it's going to use animation by a series of bitmaps. And we're also going to have something called a card gap. And I'm going to set it to 3. And what that's going to do, let's say the first card dealt is at 2. And you have a gap of 3, the next card can't be a 3, a 4, or a 5. So the worst you're going to get is a 6. And what that does is guarantees that you have a chance to win. If you get a 2 of spades and a 2 of hearts, there's no way you can win, and that's no fun. So in our timer, we're going to say if dealing cards is greater than 0, and the first thing we want to do is we want to get rid of the dealer, so we're going to say show board view equals false, and then we're going to set, because we're going to have the cards there, and now the header, we're going to need a header image now. So what we got to do is we got to create a header image. We're going to do that up top. So here's a board image, it's a string. We're going to have a header image. That's either going to be the logo or it's going to be the hands dealing the card. Header image, and the first one is going to be in between logo. And so now in our content view, instead of just right here, instead of doing the in-between logo, it's going to be ViewModel dot header image. And now for the timer, what we're going to put for the header image, the first time through, it's going to be, now if you look at our assets, it's going to be hands 5, hands 4, hands 3, hands 2, hands 1. And it's going to animate through it. So back to our content view. So the header image is going to equal hands, and then we're going to string interpolate, and it's going to be dealing cards. So the first time dealing cards is going to be 5, so it'll be hands 5. Then we're going to say dealing card minus equals 1. And if dealing cards equals 0, if dealing cards equals 0, that means we have gone all the way through the animated bitmap, and now we need to assign the cards. So if per card equals 1, we're going to assign card 1. So we're going to say card 1 equals int dot random in first card, last card. Capital int. When we first come in, if it's the first card, I'm going to set that back to 0. And then we're going to increment cur card. So for the next time it comes in, it's going to be card 2. And now we're going to set dealing cards back to 5. And it'll start dealing again. And it'll be assigned to card 2. The second time through, we're going to be doing card 2. So we're going to say, we're going to do just like we did here, card 2. Equals int random. We're going to increment now we need to make sure that there's the gap in between card 1 and card 2. So what we're going to do just like we did before. We're going to use a let constant for card 1 because it's not going to change, and that's the protocol. If it's not going to change, you make it a let constant. Otherwise, it's going to be a var. So card 2 is going to be a var. So this is going to be int card 1 equals card 1 divided by 4. We're not going to add 2 to it. It can be 0. Start at 0, doesn't matter. And then card 2 is going to be a var because it's going to change. And then we're going to say while absolute value of int card 1 minus int card 2 is less than card gap, we're going to assign card 2 again. So card 2 is going to get reassigned the number, and then int card 2 is going to get recalculated. Don't need the var. So it's going to keep doing that until card 2 has a proper gap. And then we're going to say game state equals game state.next. So it's going to go to player 1 deal or hit me. And with the new state transition, let's go ahead and say, we're going to say player hit me. What am I missing? File name. So we're going to go ahead and play the auto file for the new state. Let's go down where we process the button. This is what's going to kick everything off. So when we process button, when we say deal, we used to do a static, which would just put cards on the board that we don't even have any animation at all. So what we're going to do now is we're going to just kick off the animation by saying dealing cards equals 5. Now before we rerun this, I want to make sure everything is in sync with our timer. I might have changed this outside. This used to be 0.2. I changed this to 0.5. So make sure in your content view the timer triggers every half second. Otherwise, when the cards get dealt, it's going to be much too fast. The audio delay used to be 25. I changed it to 15. So let's run it, and let's see if we get our cards dealing in animation.
Let's play. Player 1. Deal the cards.
Perfect.
Player 1. Make your bet and hit me.
Just what we want. So what you may have noticed there is that when the dealer zoomed in, it was scaled. But when he zoomed out, he just disappeared. And why is that? We toggled the player by showing, let's go to the timer, by show board equals false. And if we go to the content view, if we go to where show board is, there's a transition. Why didn't it scale? And the reason is what we do in the initialize new game is with animation, we change the state. And what we did on the timer is we just changed the state. Now we could wrap this in with animation, but what I want to do is I want to make a function that you call that does the extra legwork. So down here, I'm going to go right underneath process button, or no, initialize new game. Right here, I want to say func display board image. And I want to show what image it is because we are going to be swapping a couple images in and out when the game starts over or when a player loses or a player wins. So it's going to be image, and that's going to be a string. And we're going to say zoom in, and that's going to be a bool. And that's whether it's getting from smaller to larger or larger to smaller. So if you're zooming something in, it'll get from smaller to larger, but if he's already zoomed in, it won't do anything. And what we're going to do is board, that's what we're going to say is board image equals image. And then we're going to say with animation, show board, we're going to do exactly what we did here, except for we're not going to always say true. We're going to say whether it's zooming in or zooming out, and it's going to be the zoom in variable. And then up in the timer, instead of just saying showboard equals false, that will give us the state variable, and that will give us the transition. But the third thing we need is when we toggle the transition, we need to say with animation. So we're going to say with animation. The difference is we're going to call this function that's going to call the toggle show board view, but it's going to be wrapped in with animation, and you will see the dealer zoom out. So let's go up to the timer. So we're not going to just say show board equals false. We're going to say display board image. And the image is going to be in between board 2. And the zoom in is going to be false. So when we start dealing the cards, we're going to zoom him out. And let's see what that does.
Let's play. Player 1. Deal the cards.
There we go. A nice smooth transition. Just what we want. Now for card 3, when we did the hit me, all we did was call did win, which resolved card 3. But now what we're going to do, deal card 3, and when the deal times out, we're going to do what we did in did win. And there's did win. Card 3. So we're not going to do this anymore. So on timer, if dealing cards, so we're going to say if card equals 1, we're going to do card 1, then we're going to say else if card equals 2, else we're in card 3. And what we're going to do is we're going to if dealing cards equals 0, we're going to do what we used to do and did win. We're going to resolve card 3, and then that's if. And then we're going to call did win. Oh, we've already got dealing cards equals 0. We don't need that. We're going to check card 2. We're going to did win. But we also need to say card equals 1. So the next time through here, it's going to deal the first card. And that should do it. So let's run it and see what we got.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
All right, so we
Player
need to
1.
reset the cards.
Make your bet and hit
for our
me.
next deal. To reset the cards, I'm going to create a function right here. And I'm going to do exactly what we did here in the initialize game. And right here, I'm going to call reset cards. And then on process button, right when we hit the deal button, I'm going to call reset cards. So let's run it and make sure everything is working.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
So everything seems to be working. In our next video, we're going to use a different type of animation by making an offset for the cards, and then with animation we're going to make the cards move to the offset as if the card is sliding across the table, and we're going to give it a duration to make it how fast it's going to slide. So I will see you in the next video. Hello, this is Randy again from Programmer's Zen. We are now on part 6 of how to make a game with SwiftUI. And in this video, we are going to create some offsets to make the cards slide across the table and spice up our animation a little bit. So without further ado, let's get started. So the first transition we're going to do is we're going to bring a hand down and slide the cards off the table. Now to do that, I'm going to add 2 variables. The first one is going to be show hand, which is going to make the hand appear. And initially it'll be false. And the next one is going to be the offset variable. So it's going to be publish var. It's going to be offset. It's going to be CG float. And initially it's going to be 0. So we're going to go to the content view. We need to add the dot offset. It's going to be in the X direction, and it's going to be offset by ViewModel dot offset. I got an extra paren. We're going to do that for each card. And then what I want to do is on top of card 2, I'm going to make a Z stack. And we're going to add a hand that is going to come down. And it's going to slide the cards off the table. And it's going to be resizable. It's going to be scaled to fit. And we're going to add the offset. So back in the view model, we have the delay deal cards. We're going to use the timer to make a delay clear cards. So down in our timer section, we're going to say delay clear cards. So if delay clear cards is greater than 0, we're going to say delay clear cards minus equals 1. And then if delay clear cards equals 0, we are going to, with animation, ease in out, and we're going to set the offset to 500, negative 500. It's going to move it 500 units. And then what I want to do when delay clear cards gets down to 3 ticks left, I want to show hand equals true. And then when we push them off the screen, I'm going to edit this video right here. This is done later, but you don't want to hardcode -500. That's not even going to be enough on a large device to get the cards off the screen. What you want to use is UI screen.main.bounds.width. That's going to give you the width of the screen in either orientation, and that's how far you want to move it, and that will work on any device. Show hand equals false. So down where we check for a win, right here where we do the delay deal cards, what I want to do is call delay clear cards. And wait just a little bit longer. So what I'm going to do is multiply this by 1.5, which is the same as saying 3 times audio delay divided by 2. Then it'll deal the cards. So you look, hand will come down. You'll see it for 3 ticks for 1.5 seconds. It'll slide it off the table, and then half the play audio delay later, it will start dealing the cards. Let me look this over real quickly. So in our timer, if delayed clear cards is greater than 0, we're going to minus equal 1. When it gets down to 3, we're going to show hand equals true. And then we're going to move it off the screen and then show hand equals false. And we have a delay clear cards equals 0. And we have a show hand bool equals false. And in our content view, we have to add if show hand. Otherwise, it's gonna we'll see it. So even though the show hand was false, it doesn't check for it here. Okay, I think it should be good. Let's view model show hand. All right, let's run it, and let's see how it looks. I like using the simulator because it's bigger on the screen, so you can also do it over here in the preview if you'd like. All right.
Player 1. Deal the cards. Player 1. Make your bet and hit me.
Let's see if the hand clears the cards. There's the hand. And that was a little fast. I'm going to slow it down, so we're going to add a duration.
Player 1.
So in our timer now, we got to go back to the view model where we do it with animation. We have to add a duration. And let's make it 0.75, 3/4 of a second. All right, let's see what happens.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me.
The hand didn't move.
Player 1. Deal the cards.
See if we can figure out why. Alright, now why did the hand not move? Image hand, resizable, scaled to fit, offset. It has an offset just like the other ones. So look in the view model. The only thing different between the cards and the hand is during the animation we say show hand equals false. I wonder if that's got anything to do with it. So what I want to do, I want to remove it from there and I'm going to add it here. So it won't fade out until it's already off the screen. And the other thing I'm noticing is we set the offset, but we never set it back to 0. So what we're going to do is we're going to do that here also. And let's see if everything works now. Alright, I think that might fix it. Let's run it and see what happens.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me.
Alright, let's see if it goes a second round.
Player 1. Deal the cards.
Yeah, if the offset was minus 500, that would have got dealt off the
Player
screen.
1. Make your bet and hit me.
Now we should see the hand. And it works. Now we need to do one more thing. We are resetting it when they deal the cards, but if there's a game over, it won't deal the cards, so that won't get reset. So I'm going to, where we initialize new game, we are going to reset the offset and hide the hand. Now the next animation I want to do is when the bitmap is finished with the hands ready to deal the card, it just magically appears in its proper place. What I want to do is set the offset to the center of the dealer's hands, and then with animation set it to 0, and it'll animate to where it's supposed to be, giving an illusion that the dealer dealt the card. So now we're going to animate the dealing of the card. Instead of when the hand's finished dealing, it just magically appears in place, we are going to animate it from the dealer's hand to where the card belongs. And this diagram shows how we're going to calculate what the offset is, and we're going to do it just like we move the cards off the table. By setting the X offset off the table, it moves it with animation, it slides the cards off the table. What we're going to do is we're going to calculate an X offset and a Y offset. We're going to move the card there, and then we're going to animate it to where the X and Y offset are 0, 0, which will animate it into its place. So what this diagram is showing us is we want to move the middle top of card 1 to the very center of the animated bitmaps where the hands are dealing the cards. And the coordinates for the dealing of the hands dealing the cards, we're going to call that the view frame. So the X coordinate is going to be the origin plus the width divided by 2. And the Y coordinate for the center of the bitmap is the Y origin plus the height divided by 2. And for the card, the X coordinate is going to be the origin of X plus the width divided by 2. And then the Y coordinate is just going to be the Y origin, which will be the top. And to calculate the offsets, we're going to subtract the view frame X from the card 1 frame X, and we're going to subtract the view frame Y minus the card 1 frame Y. And that will get us X and Y offsets, and we are going to set that for each card. We're going to calculate it, and we're going to move the card to the center of the bitmap that's dealing the hands that are dealing the cards, and then when we show it, it's going to magically appear there, and then we're going to, with animation, move it to 0, 0. So let's see what that looks like in code. So the first thing I want to do is let's go to the ViewModel and add our variables. I'm going to add them them right here. So they're all going to be published. And we're going to have a card 1 offset. It's going to be a CG size. That's a width and a height. Equals .0. And we want 3 of those, 1 for each card. And then we're going to need the coordinates of card 1 and coordinates of the bitmap where the hands are dealing the cards. And I call that the view frame and the card frame. And that's going to be a CG rect, which is an origin and a width and a height. So that's the view frame and the card frame. And let's block these together. And let's make this card 1 frame to keep it consistent with my diagram, because we are going to get the coordinates of card 1. So now we need to go to the content view, and we need to go to card 1. And right here, let's give us some room. What we're going to do is we're going to add that offset. So card 1 is now going to have 2 offsets. The first one for X is going to be ViewModel.card1 offset dot width, and Y is going to be what the autocomplete said, ViewModel.card1 offset dot height. And then that's the offset. Now to calculate where it's at, we're going to do this in the background, so it won't affect anything. And we're going to create what's called a GeometryReader. And what that's going to do is it's going to give us the coordinates of card 1. So it's going to give us an origin and then a CG size, which is a width and a height. So we're going to say GeometryReader, and then we're going to give it geometry. Some people just say geo. Geometry N. We're going to give a color of .clear. And then when it appears, it's going to recalculate this every time it gets resized or redrawn. We're going to say ViewModel dot card1 frame equals geometry frame m dot global. That is correct. We're going to do the same thing for the header. So what we're going to do is we're going to give it a background. And we're going to get its coordinates. So the image header right here. And then we're going to say view frame. So now view frame is going to have the origin and the width and the height. So now what we're going to do is we're going to go back to the view model and we're going to calculate the offset. So I'm going to go to the bottom. And right here, we're going to create a func that's called set card1 offset. And it's going to use that formula that we had on the diagram. Card1 offset dot width equals view frame dot origin dot x minus view frame dot width divided by 2. And then we're going to subtract card frame, and it's the formula, but it's the whole formula. That minus will get messed up if you don't put this in brackets. I'll show you why in a minute. And it's going to be card 1 frame dot origin dot x origin dot x minus card 1 frame dot width divided by 2. Now, if we didn't put this in brackets, these should be plus. It's the origin plus half the width on both of them. Now, if we didn't put this in brackets, that plus would be incorrect. If you take the brackets away, you need to make this negative, because this is the same as saying -1 times this. So -1, when you multiply, that would become negative if you got rid of the brackets. So it's safer to do that. And then the origin dot y, the offset dot y, card 1 offset dot height equals view frame dot height divided by 2 minus card 1 frame dot origin dot y, and that's it. Card 1 frame origin dot y, that's the top of the card. And you don't need the brackets. So now when we're dealing the cards and we get its random number, right here is where it magically appears. We're going to set card 1 offset, and we're not going to do any animation. So when we run this, the card should be up in the dealer's hand. So let's see what we get.
Let's play. Player 1. Deal the cards.
All right, so that's what we want.
Player 1.
Now we have to animate
Make your
it
bet
to
and
its
hit
proper
me.
position. So now we need to add the animation. And we're going to do just what we did here. We're going to do that right here after the card appears. So we're going to say with animation, I'm going to put this on one line. And it's going to be card 1 offset equals .0. All right. Let's see what it looks like.
Let's play. Player 1. Deal the cards.
All right, it works. All right, now we got to add the other 2 cards. But the first thing I want to do, I think that was a little bit slow. I'm going to make it 0.5. So what we're going to do is we're going to set card 2 offset. And then with animation, we haven't made card 2 offset yet, so we're going to get that error, but after we get the card, we are going to, with animation, we're going to set card 2 offset to 0. And then we're going to do the same thing for card 3. And with animation, we're going to set it back to 0. And now at the bottom, we are going to make set card 2 offset and set card 3 offset. Now this is going to be quite simple because the X for card 2, while card 1 needs to go to the right to get to the middle of the dealer's hands, card 2 needs to go to the left. So the offset is going to be just the negative for X of what the X was for card 1. And the height is going to be the same. And for card 3, X is going to be 0 because he's centered. So for card 3 offset, the width is going to be the 0. And the height is going to be the same. They all got to go up the same distance. Now in the content view, we've got to add the offsets for card 2 and card 3. And we don't need to do the geometry reader because we use card 1 for all of them. So card 1 offset So here for card 3, it's going to be card 3 offset dot width and card 3 offset dot height. And for card 2, the offset is going to be card 2 offset dot width and card 2 offset dot height. We use card 1 offset for all of them. That's going to be card 2 offset dot width and height, and this is going to be card 3 offset dot width and height. So let's see what we get.
Player 1. Deal the cards. Player 1. Make your bet and hit me.
So that works. And the last transition I want to do is in the timer where you say player 1 you win, player 1 you lost. And so we'll replace sound player 1 you win. I want to scale in it's an image in our assets called winner outro. And when it says player 1 you lose, I want to scale in loser outro. Now we zoom in for both of them needs to be true because we're going to be scaling in. Make it go from smaller to bigger. Zoom in true. And also I want to reset the cards. That's going to set them all to no card. Make sure they're not showing. So let's run it.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me.
Bet it all. We're going to either win or lose.
Player 1. You lose.
Okay, that should be about it for this video. Stay tuned for my next video where we're going to start animating sound, starting with paying off the player when he wins the pot. Want to learn a language? Language Book Reader from the App Store teaches languages from arguably the best resources available. All the language courses were developed by the government and are public domain, making them the best and cheapest courses available. People used to ask, how do government officials learn a language so fast and efficiently? The answer is simple. They use these courses. Hello, this is Randy again from Programmer Zen, and we're on part 7 of how to build a Swift game. In this game, we're going to start with sound animation, and hopefully we're going to finish up all the single-player game stuff. And in the next video, we'll convert it to a 2-player game to conclude the session, so hopefully we'll get through this. So before we get into any transitions, I want to create a component that gives us 3D text instead of just a flat text on the board. So what I'm going to do is the first thing I want to do is I want to create a new folder. It's called Components. And I want to create a file. So I'm going to create a file from a template. And it has to be a SwiftUI view. It's going to be a view for our component. And I'm going to call it rounded text. And so for the rounded text, we're going to have some parameters that come in. First one's going to be a title. That's a string. Then we're going to have a width and a height. We're going to have a height. It's going to be an int. And then we're going to have a red, a green, and a blue, which is a better way to fine-tune colors instead of just using the default color.white, color.black, color.red. And we're going to say let green be an int, red, green, and it's going to have a blue. And we're going to do this pretty much just like we did the button that we had, our game button. We're going to use a Z stack, and it's going to be wrapped in a frame, and it did us good. The auto completion made, it's not really an int, it's a CG float for frame. Now if you're, as we did in our content view, we say frame, we give it a hard-coded number of 250. It actually makes that into a CG float. So it's supposed to be CG float. The auto-completion did it for us. So we're going to have a frame of the width and the height that was passed in. Now what we're going to do in this Z stack is we're going to have some round rectangles. And I want a quarter radius of 20. And we're going to have 4 of these. Now the first one's going to be just like we did on the button. It's going to have a foreground color of white and no padding. Now for the second one, we're going to make a color for this that's based on the red, green, and blue that got passed in. So we're going to say foreground color. And the way you do that is you make, just like we have color dot white, we're going to have a color, but we're going to have a red, and it's a double, so we're going to say double. And we're going to do the red that was passed in. We're going to do green, double green that passed in, and blue, double blue that passed in. It doesn't like this comma. And it doesn't like foreground. Okay, that's our first rectangle. Now what we're going to, and this one's going to need padding or you won't see the white. So we're going to go dot padding, and we're going to just do 3 all the way around. So that's how you do that. So we're going to do now for the next one, what we're going to do is we're going to add a little number to the, oh, and also we pass in a number between 0 and 255. It needs to be between 0 and 1. So we got to divide all these by 255. So it's going to be the whatever we pass in for green, it's going to be minus 255. And that's going to be divided by 255. Let's do that again. All right. So we're going to have red. We're going to add some numbers to it. For the first one, it's going to be 4, 15, and 30. So we're going to add 4. We're going to add 15 to the green, and we're going to add 30 to the blue. And then this padding, we're going to make them a little different for each one. It's going to go all the way around, so it has an effect that the light isn't straight on top. So we're going to do a dot top. We're going to do a dot bottom. We're going to do a dot leading and a dot trailing. And dot trailing. And for the first padding, we're going to do 12, 10, and 9. So it's going to be 10, it's going to be 10, and it's going to be 9. And we're going to do the same thing for the next one. It's going to have, we're going to increment the color a little bit. When you add a number to the red and the green and the blue value, it makes it brighter. So adding 4 to it makes it a little brighter number. This one's going to be 12, 30, and 40. So we're going to add 12. We're going to add 30. And we're going to add 40. And for the padding, it's going to be 18. It's going to be 20. It's going to be 20. And it's going to be 18. And then what we got to do is we got to do the text on top of the, this is actually a text button, so it's going to be the title. So we're going to do just like we did for the game button. We're going to have a big white corner radius. On top of the white corner radius, we're going to have a different color. So it's going to have a white border. We're going to give it padding of 30, so the border is going to be padding of 3, so the border's going to be 3. And then what we're going to do is we're going to make it a little brighter by adding a 4 and a 15 and a 30 to the red, green, and blue components. We're going to give it a padding, and what the first one's going to be is going to be, you're going to see the white border, and it's going to be the dark border that meets the white border. Then we're going to give it one more, which is going to be a little brighter, and it's going to be the bright part on top. So that's that. Now what we need to do is we're going to go to our content view, and we're going to use this. So what we print out, we're going to print out either the pot or the bet text. So let's do the pots. The text is going to be the title. And there's that. And then we're going to have a width and a height. We're going to make the width 175. We're going to make the height 50. And the red and the green and the blue, we're going to pass in 110. Oh, I lost my green and blue. The green is going to be 20. And the blue is going to be 205. Now let's give it the canvas. Let's see what it looks like. Oh, we got an error. I don't think it likes this. Oh, I didn't make it rounded text. So it likes that. Let's see what it looks like. Oh, our rounded text. We have to do this. So we're going to give it a title. And we're going to take what it gives us. Now let's go back to content view. And there's our button.
Let's play.
Now the text is black. So we need to give it a foreground color. Color.white. And we need to give it a font. It's going to be .title. Okay, let's go back to the content view. And there's our button. So we're going to do the same thing.
Let's play.
For the bet, we're going to give it rounded text. And this is going to be the title. And then we're going to add a width. And it's going to be 175. And we're going to height 50, 110, 20, 205.
Let's play.
And there it is. Now what we need to do is I need to put the bet under the slider, which is easy enough to do. Oops, I need to cut it. And we have just made a component.
Let's play.
That we can use on any text field that's going to
Let's play.
Make it look just a lot nicer. So now when the player wins, we're going to make it more Las Vegas style. Right now all we do is increment the player score and decrement the pot. We're going to actually animate it with sound. And we're only going to do it when you win. When you're in Vegas and you lose, you just lose. But when you win, all kinds of bells and whistles go off. So we're going to imitate that. So the first thing what I'm going to do is we're going to do like we always do when we're playing a sound and we have to wait for a delay. Is I'm going to say delay, payout win equals play audio delay. And then we're going to go up to the timer and we're going to say if delay payout win is greater than 0. And we're going to do like we always do. We're going to say delay payout win minus equals 1. And then we're going to say if delay payout win equals 0. And what we're going to do is we're going to check to see if a bet was made. If not, we're just going to call check win. So we're going to say if int bet is greater than 0, then we're going to set another variable to actually do the playing of the payout win. Else, we're going to call check for win. All right. If int bet is greater than 0, and this is incorrect, it should be like this. It should be greater than 0. So if the bet is greater than 0, that means they did a bet. So we're going to create another variable called playing payout win equals int bet. And then up here, we're going to say if playing payout win is greater than 0, then we're going to play a sound. And then payout win equals 1. And the asset for payout sound is called payout win. And then we're going to say pot amount minus equals 1. Bet minus equals 1. Player 1 score plus equals 1. And then we're going to say if playing payout win equals 0, we're going to check for win. So now we're going to add the variables for these two timer functions. We're going to do it right here. They're going to be private. So it's going to be delay payout win, and it's going to be playing payout win. And it's colon int. All right, so what I want to do now is I want to give our audio player a little more functionality. And what I'm going to do is I'm going to add two functions to it, and they're real simple. The first one is going to return true if the audio player is currently playing an audio file. And now audio player is actually declared as a conditional. That's what this question mark is for, and it'll be null or nil until this line is actually executed to give the player a value. So if you try to call is playing before you load an audio file, and this is going to crash. So we're going to use what's called a guard. And what guard's going to do, we're going to say guard let player. So that player is going to be a local variable player, local to this function, equals the global player. If that fails and the player isn't initialized, it's going to return false, so it's not playing. If that variable is true or not nil, then it's going to return true if it is currently playing an audio file. So the next one I want to do is stop, and we have to do pretty much the same thing. Player's conditional. You don't want to just say player.stop because player might be nil, and that will cause an error. So we use the question mark, and we'll say player question mark dot stop. And if it is playing, it will stop. If it's uninitialized, it won't do anything, but it won't be playing anyway. And then back here in our content view model, what I'm going to do is we're going to check to see if it's playing. So if player.isPlaying, and we're going to say if not playing. So if it's not playing anything, we're going to go ahead and load it and play this file. If it is playing, it's going to skip, and that'll get rid of the chop. And then down here, where we check when we're all done paying out, we're just going to say player dot stop. And the one last thing we need to do, we're checking for win right here. I think we're still doing that down at the bottom. We don't want to do it twice. So did win. Yeah, we don't want to call it here. We're going to call it now after we done paid off the pot. But if the player doesn't win, we call check win through this channel here. We have to call it here if you lose, otherwise it'll never get called. So we want to call check for win if you lose, otherwise we're going to delay payout, and then it'll call check for win through here, otherwise we got to call it if you lose. Let's run this and see what we got.
Let's play. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. Deal the cards.
We didn't bring the dealer in soon enough, so let's see what
Player 1. Make your bet and hit me.
So where we initialize new game, we need to bring the dealer in, and it's going to say let's play. Initialize new game. Now we changed this. We used to do animation. We made that a function down here. So this is going to be display board image. And it's going to be in between board 2, and we're going to zoom in. What I want to do is zoom out first. So what we're going to do is we say show board equals false. We'll remove it. So then there'll be a transition when we say, it's board image. And that should zoom it in. And then we don't need this anymore since we made a function. And so we turn that into a function down here, which basically going to be the same thing, reset with animation, ease in and out, and we made it the bool, whether it's going to zoom in or zoom out with board image. Okay, that should fix that problem. Now let's work on the buttons at the top that we have. There's 2 buttons. One is for the settings, and the other is for muting the sound. So in the content view, where we display the header image, we're going to have a button on both sides. So what we're going to do is we're going to make an H stack. And then we're going to have a button for the settings. And it's going to be what's called an SF symbol. And it's going to be gear shape. And that's the shape for settings. And it's going to have a font. Now the font determines the size of these SF symbols. So the bigger the font, the bigger the symbol gets. So I'm going to use large title, and then it's going to have a foreground color also, and it's going to be colored out white. And we're going to have some padding. It's going to be dot leading 35 and dot padding on the bottom. We're going to do 50. So that is going to be the settings button. We're going to do a spacer, and then we're going to have the header image, and then we're going to do the speaker. And it's going to have the same settings as this, almost. Except for leading is going to be trailing. Alright, so there's our images for our buttons at the top of the page. Alright, to implement the speaker, I'm going to create a Boolean variable in the ViewModel, and it's going to be a var. I'm going to call it play sound. And it's going to be Boolean, and to start off with, it's going to be true. But I'm going to give it, it's going to go to app storage. And what that does, what that's going to do is anytime that variable changes, it's going to write it to local storage. And app storage, you need to give it a name that when you're going to reference it, which I'm going to keep it the same as the variable name. So what that's going to do is anytime the variable that we got play sound toggles, it's going to write it to app storage here, and that's going to be saved across sessions. So in other words, if you turn off sound and close the program down, close the app down, the next time you start it, the sound will be the way the state it was in when you did it. So we're going to go to content view, and what I want to do is I want to give it the status of the speaker. So this speaker needs a string, and what I'm going to do is I'm going to say ViewModel play sound, if that's true, we're going to have the speaker image. Otherwise, we're going to have speaker.slash. Now, if you wonder where I get these at, if you click this plus button up here, and you click on this one right here, it gives you the symbols you can use. And if you do a search on speaker, here's the ones I'm using. So here is speaker, and the one with the line through it is speaker slash. So that's what I'm using for this. And so we need to make a button out of this. And the action is going to be ViewModel.playSound.toggle. And then we're going to make the image the label. So there's our button. I'm having a hard time spelling today. ViewModel.playSound. Okay. And we want a spacer in between the image and the audio button. And then the only other thing we need to do, now the app storage is global. So we're going to move the app storage to our audio player. And it'll know whether play sound is true or false. And when we call play sound, I'm going to say if play sound, then we're going to do it normally, otherwise it's just going to fall right through. And that should take care of toggling the sound on and off. Well, that about does it for this video, so join me in the next video where we're going to make this a two-player game. Hello, this is Randy again from Programmers Zen. We are on part 8 of how to build a game using SwiftUI. And we're going to make this into a two-player game playing against the computer. So let's get started. All right, let's make this a multiplayer game. We're going to start by uncommenting player 2. Then we're going to go to our view model. Our model. And we're going to add player 2. So we have a player 1 deal and a player 1 hit me. We're going to add that for player 2. Player 2 deal, player 2 hit me. And we have a description for player 1 deal, player 1 hit me. We're going to add it for player 2. Player 2 deal, player 2 hit me. And we have our audio file. It's going to be player 1 deal, player 1 hit me. It's going to be player 2. Player 2 deal, player 2 hit me. And we're going to play player 2 deal, player 2 bet. And then we have our status. So we're going to have case player 1 deal, player 1 hit me. It's going to be player 2 deal. and player 2 hit me. And we need to do the same thing for status text 2. It's going to be player 2 deal. And player 2 deal the cards. Player 2 hit me. Player 2 make your bet. Player 1 deal, player 1 hit me. Player 2 deal, player 2 hit me. Player 1 deal, player 2 deal. This should be player 2. Player 2 bet, that's right. Player 2 deal hit me, and player 2 deal hit me. That's got it. All right, that should do it for the model. Now in our view model, we are going to add a variable to keep track of our player. We're going to add it right here, like cur player int equals 1. And then in our timer function, where we're dealing the cards, where we delay deal cards. So we're going to say if cur player equals 1, else and then what we're going to do is we're going to play the sound file. It's going to be gamestate.audio file. I got an error with cur player. What'd I do? Spell it wrong? Let me see. Yes, it should be a capital P. And so that's right. There should be player 2 deal. Now let's go add the player 2 score up top where that's declared. Player 1 score. And player 2 score. All right, in our wrapper function, let's add player 2 score. That would be right here. And then in our context view, we need to change that to use the wrapper function. So it's going to be just like player 1 score. It's going to be ViewModel player 2 score. Now back in the content view model where we check for win. If player 1 score is less than 1, player 1 loses. But now we need to check for player 2 score less than 1. And if the game is still going, we have to change players. So down here, we are going to say if cur player equals 1, cur player equals 2, else cur player equals 1. So we got to have a space between equals and 2. And it says cannot assign, it is a let constant. Oh, did I make cur player a let constant? Let, that needs to be a var. That needs to be a private var. And let's keep these up here where our privates are. So let's go back, see if it fixed it. Check for when, curve player equals 2. Okay, so that fixed it. And then up here in did when, what we want to do is when you lose, if curve player equals 1, player 1 score gets decremented, else player 2 score gets decremented. And then our delay payout when in the on timer, and our timer, if curve player equals 1, player 1 score gets incremented, else player 2 score gets incremented. And when we initialize a new game, we have to add player 2 score. So now we're going to simulate player 2 dealing the cards and hitting me. So what I'm going to do is I'm going to add 2 more variables. One of them is going to be delay get player 2 cards. And the other one is going to be delay player 2 hit me. And now down in the timer function, we are going to create 2 countdown timers, just like we've been doing. One for the delay get player 2 cards, and one for the delay player 2 hit me. So here's the timer. And we're going to do it just like we've always done. So it's going to be if delay player 2 card is greater than 0, and delay player 2 hit me is greater than 0. And then we're going to say if delay player 2 card equals 0, we're going to fire the event. And of course we have to count down the timer. So we're going to say minus equals 1. And then we're going to do the same thing here. And now what we're going to do here, to get the cards, we're going to do exactly what we do in process button. When player 1 deals the card, we're going to reset the cards, and we're going to set the dealing countdown timer. So they will deal the first 2 cards up until the hit me. And then when the hit me comes, we're just going to reset dealing the cards, and then it'll deal the third card. And the only difference is when player 2 gets done dealing, and it's going to call hit me, the computer's got to make the bet. So we're going to make a function called make bet, and the computer is going to calculate player 2's bet. And the other difference is when dealing the cards, if the current card is 2, after dealing the second card, we got to call delay player 2 hit me. So it's going to say player 2 make your bet and hit me. If it's the second player, we're going to kick off the countdown timer to go ahead and make the bet and then deal the cards. So we're going to down to the bottom right here. We're going to make a function called make bet. And what we're going to do is we're going to see what the chances of us winning. So what we need to see is how many cards there are that are winner cards. So I'm going to say int card 1, kind of like what we did before, equals card 1 divide by 4. And we don't need to subtract it from 2, so it's going to be between 0 and 13. And we're going to say let and card 2 equals card 2 divided by 4. And then we're going to see how many cards are a winner. So we're going to say let num cards equal absolute value of int card 1 minus int card 2. So what that's going to do, let's say we have a 5 and a 3. So the absolute value of 5 minus 3 is 2, but only 4 is the winner card. So we're going to say minus 1. And then we're going to multiply it by 4 since there's 4 cards in each suit. And then what I'm going to do is I'm going to make the bet say num cards, and since bet's a double, num cards divided by 50. Why 50? 2 of them are already on the table. So if we're going to use that example, 4 cards are winners. My odds of winning is 4 out of 50. And then what I'm going to do is multiply it by the player 1 score. Player 2 score. So if you have 80 points and you have a 20% chance of winning, my bet's going to be 80 times 0.2. And player 2 score also needs to be a double. That's the AI behind making a bet. And then the only other thing that we want to say is if bet is greater than the pot amount, need one more bracket. If bet is greater than pot amount, then bet equals double pot amount. And that's basically the logic behind making a bet for player 2. The next thing we have to do is, now that this is a 2-player game, the pot can run out of money, but both players might still have some, and the game will be over because there's nothing to win. So we need to add an ante. So let's add it to our model. And what I'm going to do is I'm going to call it player 1 ante and player 2 ante. And the reason for that is if it's player 1 ante, as soon as you say game state equals game state.next, it'll be player 1 deal. And if it's player 2's deal, and it needs to ante, we're going to set the ante to player 2 ante. And that way game state.next will be player 2 deal. And down here in the description, it's just going to say deal. So what we're going to do is we're going to have this as player 1 deal, or player 1 ante, or player 2 ante. The button's going to say deal. And for the audio file, right here, it's going to be ante up, player 1 and player 2 ante. And player 2 ante, it's just going to be ante up, ante up. And for the text, it's just going to say ante up. So it's going to be player 1 ante. It's just going to say ante up. And it's going to be the same for status text 2. Player 2 case dot. And then it's going to be the same for status text 2. So let's go back to our content view model. And the first thing I want to do is I want to create a let constant for the ante amount. So we're going to call it we're going to say let ante equal, and I'm going to make it 10. The player gets 20. And then we're going to create an ante up function. We could put it anywhere. I'm going to put it right here after check for when. It's going to be called ante up. And what it's going to do is it's going to say pot amount equals ante times 2 and player 1 score minus equals ante and player 2 score minus equals ante. And now in process button, we used to go with game state equals player 1 deal. Now we're going to go to game state equals dot player 1 ante at the very beginning. And then we're going to ante up. And since we used to go straight to deal, we have to delay dealing now so it has a chance to say ante up. So we're going to say delay deal cards equals player 1 audio. And now since we're anteing up, where we initialize the game, the pot amount needs to be 0 because the ante is going to fill it up. And then up top, where we first start, the pot amount is going to be 0. Well, let's run it and see what we got.
Let's play. Ante up.
It anteed up, but it didn't animate. Let's see if it goes. Yeah.
Player 1.
It went
Deal
to
the
next
cards.
state.
Player 1. Make your bet and hit me.
Now let's see if it goes to player 2.
Player 2. Let me deal your cards. Player 2. Let me make your bet and hit me.
Okay, that worked. So it seems like it's working. All we need to do now is to add the animation for the ante. All right, so we're anteing up when the game first starts and process button. So right here where we start, we're just doing a static ante up. What we're going to do is I'm going to create another variable called delay playing ante up, and that's going to equal play audio delay. And then I'm going to add the ante amount. So what it's going to do is it's going to do a countdown timer, and it's going to count down until only the ante amount is left. And then it's going to make the audio sound for the ante. And we're not going to deal the cards here. We're going to delay playing the ante up, and then when the ante's done playing, it's going to deal the cards. So let's go create this variable. We'll do it right here. All right, and now we got to go to our timer function and implement this. So in our onTimer function, we're going to say if delay playing ante up is greater than 0, delay playing ante up minus equals 1. All right, the auto completion did that. But we only want to do that is if delay playing ante up is less than ante. It's going to count down before it starts playing that. And it's going to say if is playing, and then we're going to decrement the player and increment the pot. So it's going to be pot amount plus equals 2 player 1 score minus equals 1 player 2 score minus equals 1 if delay ante up equals 0, delay playing ante up. If delay playing ante up equals 0, that's when we're going to kick off the dealing. So we're going to say game state equals game state dot next. Delay deal cards equals play audio delay. Now we don't really need a long delay here because we're all done playing the ante. It's just that last one, and it's very small. So we're going to divide this by 4. We're going to do a fourth of the delay it usually is. And then what I want to do is I want to zoom out the board image because we're going to have the dealer there when we're anteing. So it's going to be image is going to be in between board 2, and zoom in is going to be false. So it's going to zoom out, and then it'll start dealing the cards. All right, cannot call function game state equals, it's not a function. It's not ante up, it is ante up coin sound. So let's run it.
Let's play. Ante up. Player 1. Deal the cards.
Alright, so it looks like it's working. So now what we're going to do is when during the game the pot runs out, but both players have money, so we're going to go to check win. And right now, what we do right here and check for win is we just ante up, and the amounts on the screen gets updated, but there's no animation, and then we just immediately call deal cards. Well, we can't do that anymore because we need to animate the ante up, and only until that is done can we clear the cards and deal the cards. So what we're going to do is we're going to do exactly what we do when we start up. Game state is we're going to call delay playing ante up like we do in process button. And let's go up here. So let's do the first one. We're not going to call ante up anymore because that just statically updates it. And at the blink of an eye, you see the update. And then you can deal the cards. So what we're going to do is, and we're going to remove this play sound, is we're going to delay Ante up, and we're going to make this a little bit different. We can't Ante up here. Instead of Ante up here, we're going to delay the play sound of Ante up. And now, what we're going to do is, if there doesn't need to be an Ante up, we're going to go ahead and do like we've been doing before, but we can't do this automatically anymore. So let's cut this. So now what we're going to do is we're going to say, if pot amount is less than 1, we need to ante up. Instead of just anteing up and at the blink of an eye update the score, and at the bottom start dealing the cards, we're going to say, if we need an ante up, we're going to delay the ante up so we can finish either the you win sound or you lose sound. We're going to set the proper game state. And if we don't need to ante up, we're going to go ahead and do like we've been doing. We're going to clear the cards and deal the cards. So what we need to do is down here, process button, we're going to update. We're going to update play sound to do it all in one. So we're not going to call play sound here anymore. So let's go to delay play ante up. So we're going to do something a little different here. For the delay playing ante up, instead of giving it the delay amount and waiting for it to wait, so make sure all the sounds are finished, and then call another function, what we're going to do here, since all the sounds, the delay player lose and the delay player win is a very quick sound. So we're going to wait for half the countdown, and then we're going to go ahead and play ante up. And since ante up is such a quick sound file, we can be sure that half that delay count, it will be finished before we start playing the ante up sound. So right here, we're going to play the sound file. So we're going to say if delay playing ante up equals ante plus play audio delay divide by 2, we're going to go ahead and play the ante up sound. So what we want to do is we want to reset the cards. So we'll get the cards off the table. We are going to play the sound file. And it's going to be gamestate.audio file. And then the last thing we want to do is we want to zoom in the dealer. Because we're going to be looking at you saying ante up. It's going to be in between board 2, and it's going to be true. So that's going to zoom in the dealer who's going to look at you and say ante up. So the next thing we're going to do is when the game is over, we're going to pay out the winner. So what I'm going to do, I'm going to do this a little differently again. I'm going to create a variable called delay paying winner pot, but instead of letting it time out while we hear either player 1 lose or player 1 you won and there's a lot of clapping, I'm going to set it to -2, and I'm going to check the audio player, and while it's still playing a sound, it's just going to return. And when it's done playing this sound, it's going to decrement it to -1. And then in the timer function, if it's -1, it's going to say either player 1 wins the pot or player 2 wins the pot. And then it's going to keep checking the audio player till that's finished playing. And then it's going to play the sounds to pay the winner the pot. So instead of having 3 variables to keep track when one time's out, you start another one, it's going to only have 1 variable to pay out the winner. So let's add the delay for if you win. It's not going to make a difference. It's going to get resolved in the function. So delay player winning pot. And then we got to add the variable up top. We're going to put it right here. And it's going to be a private var. And that's going to be int equals 0. So right here in the timer function, I'm going to say if delay paying winner pot does not equal 0. And then we're going to have 3 states. The first one is if delay playing winner pot equals -2. Else, if delay playing winner pot equals -1, and then we're going to say else if is greater than 0. And that's the 3 states we're going to have to play out the paying the winner, the pot amount when he wins. And this should be -1. So it's going to go from -2 to -1, and then we're going to do like we always do. Just going to count down our timer and pay out the winner. All right, so here's what it looks like when it's all finished. So what we're going to do is we're going to say if it's not 0, it could be negative or positive, but the first time through it's going to be -2, while the audio player is playing player 1, you lose, or clapping because he won. And what it's going to do is it's going to check the audio player, and if it's still playing that sound, it's just going to return. So as soon as the audio player quit playing the player 1 or lose sound, it's going to fall through past this return, and then it's going to say player 1 scores greater than 0. That means player 1 won the game. And we're going to play player 1 wins the pot. Otherwise, we're going to say player 2 wins the pot. We're going to increment this so it's no longer going to be -2. The next time it falls through, it's going to be -1. And it's going to do the same thing. It's going to sit here and wait for one of these 2 sounds to finish. And as soon as one of these 2 sounds finish, now we're going to do our normal countdown timer loop. We're going to set pay winning pot the pot amount, and it's going to fall through the loop that we're used to doing, the amount of the pot. So what it's going to do here is say if it's not playing, go ahead and play the sound. That way it does the complete sound and it doesn't get chunky. But it's going to be playing the same sound over and over. And then we're going to delay the winner pot. We're going to decrement the pot amount. We're going to increment the winner. And we're going to do that until the variable equals 0. And as soon as it equals 0, the next time we come through here, this won't get executed. And that's how we're going to pay out the winner at the end of the game to let him get all the chips in the pot. All right, before we conclude this video, I want to make one small change. It's very simple to do. But where we delay deal cards, we automatically deal player 2's card. But we don't. We make you hit a button if you're player 1. In a true board game where you're sitting around a dealer, you wouldn't have to hit a deal button. And the only difference between when we're dealing the cards is when we count down to 0, we change the game state for player 1 to deal, and he has to hit the deal button. But player 2, we go ahead and say delay get player 2 card. Now get player 2 card, really all that does is it does the same thing as when you hit the deal button. And the reason we called it player 2 is because we were distinguishing it and making it more readable to say we're only doing this for player 2, but technically we can do the same thing for player 1 and he wouldn't have to hit the deal button. So if you'd like to, I'm not going to do this. You can change this to delay get player card instead of player 2 because we're going to do it for player 1 and for player 2. But this will make it so that player 1 no longer has to hit the deal button, which is more like sitting around the table where a dealer is dealing cards. And then in the model, we're going to change the audio file just a little bit. Instead of saying player 1 deal, it's going to say player 1, you're up. And the spelling matters, so you have to have a case sensitive. And instead of player 2 deal, it's going to say player 2, you're up. Another thing we have to do is we got to deal with the game button. For instance, when the game button says hit me, if you hit me, it's going to try to deal a third card. If you hit that button again, it's going to deal a third card again. So we have to enable and disable that button, and we're going to do that. I'm going to create a variable that's going to say button disabled. So it's going to be publish var button disabled. It's going to be a bool, and originally it's going to be false. And also, if current player is 2, the button's going to automatically be disabled in the content view. So we have to make 2 wrapper functions, one for button disabled and one for current player. So down here, we're going to say current player and button disabled. And we got the wrong return types. This is type int, and this is type bool. And this is disabled. Now let's go to our content view, and let's find our game button. Let's give it some room here. So here's our game button, and what we're going to do at the end of the label, we're going to add a disabled modifier. If the current player is 2, it's going to be disabled. Otherwise, if the current player is 1, we're going to use the button disabled, which we will do the logic for after this. And we also need to do this for the slider. If current player is 2, no one has access to the slider. And also what I want to do is on the button, not only is it going to be disabled, you're not even going to be able to see it. And we're going to do that the same way that we did with the cards. We're going to use the opacity. And so the opacity, if it's current player is 2, you're not going to see it at all. Otherwise, you're only going to see it when the button is enabled. So if the button is disabled, then the opacity is going to be 0. And it's button disabled. So if current player 2, you're not going to see it. Otherwise, we're going to use the button disabled variable in the view model, which we're going to toggle on and off as necessary. All right, now let's go to the content view model, and let's see where we're going to be disabling this. The first one is when you hit the start button. When you hit the start button, you want to say button disabled equals true. And then, when the second card is dealt, you're about ready to hit me. So in delay deal cards, where delay deal cards is greater than 0, we want to get rid of the deal button. And then when it's dealing and we get to the second card, current card equals 2. We want to make sure it's not disabled because you got to hit me. So button disabled is going to be false. And when it's done paying out the winner pot, we want to add one right here. We want to say if delay paying winner pot equals 0. We want to say button disabled equals false. And when another thing we need to do right here, since this is when the game is over, when it's done paying out the pot, so what we need to do is we need to play sound game over. And when the player 1 hits me in the process button, We want to disable it so you can't hit me twice. And we want it to be disabled, so that's going to be true. And an initialize new game. And we want to make it false. All right, that's going to wrap it up for this video. And the next video, we're going to finish it up by doing the settings and the profile screens. Hello everyone, this is Randy from Programmer Zen again, and in this video we're going to cover the last two portions of building a game using SwiftUI, which is the settings screen and the profile screen. This is done using what's called sheets that pop up, so let's get started. So we're going to start with the profile sheet, and I've got it defined here. This is the way you define a sheet. I did it just above the dot on appear. So it's a dot sheet and it has one parameter, and it's a bindable parameter, and it's a bool. So when that boolean variable is true, whatever is here gets presented in a pop-up. And if you ever make that variable go false, the pop-up closes down. So in my content view model, I declared a published var is profile presented equals false. Since it's false, it won't show up. So what I'm going to do is I'm going to put something right here. We're just going to do some text. And whatever is here gets presented in the pop-up or the sheet. And what I'm going to do is I'm going to set this to true. So it's going to pop up as soon as the program runs and gets loaded. And there it is. It loaded the sheet that said profile. So what I'm going to do to show this even further is I'm going to add a button right here. And I'm going to say, and what I'm going to do is I'm going to say is profile presented dot toggle. And then for the label, I'm just going to have a text field with large text that says close. And this is ViewModel. Okay, let's run this. Since is profile presented is true, present this sheet. But when I hit close, it's going to toggle it and it gets closed. And that's basically the way a sheet works. You have one bindable variable, and this one is going to be is presented. And if is presented is true, whatever is right here in between the beginning and end of the sheet gets displayed on the pop-up. So what we're going to do is I'm going to create a profile view. So I'm going to create a view, new view from template. It's going to be a Swift UI view. It's going to be called profile view. We're going to create it. Now this profile view is going to have one parameter. It's the bindable parameter that was from is presented. So we're going to have at binding var is presented bool. And to make the preview work, we're going to have to add a variable to represent this is presented. And the way you do that is you make it, you call it previewable, and it's going to be a state object is presented. It's going to be true, and then we're going to pass this is presented, and the binding object is going to be is presented, and that is bindable. So you got to add a $sign, and that should get us a preview. And to keep in with the MVVM architecture, I'm going to go ahead and create a model for this profile view. Although it's very simple and it's probably unnecessary, the simpler it is, the easier it is to understand the way everything fits together. So I'm going to go ahead and do it. So I'm going to create a new file from template, and it's going to be a Swift file, not a view, and I'm going to call it profile view model. So here's the model for that, and it's going to be very simple. There's only a couple variables, and I'm going to use app storage for all of them. So this is going to be class, profile, view model, and it's going to be an observable object. And that's going to have 3 variables, and I'm going to use app storage for all of them. First one is going to be gender, and that's going to be an int. And it's going to default to 0, which is neither gender. And then we're going to do app storage name, and that's going to be a string, and that's going to equal blank. And then the last thing is the total score. It's going to keep track of your score. That's going to be a var total score int equals 0. Unknown attribute app storage, and that's because we have to import, we've seen this before, SwiftUI. And there's our model. So what we have to do in our profile view is we have to say state object var profile equals profile view model. Then we're going to get rid of this, and we're going to start building the profile view. So we're going to start with a Z stack, and it's going to be, we're going to give it a background of color dot blue, and then we are going to edges ignore safe area dot all. All right, so there's the background. The first thing and then we're going to have a V stack, and the first thing I want to do is do text profile, and that's going to have a font of a large title. Foreground color is going to be .yellow, and then we're going to have an image. It's going to be the profile image, so it's going to be profile dot gender, and what that's going to be, it's either going to be profile 0 if it's not a male or female, profile 1 is going to be a male, profile 2 is going to be a female, and it's going to start off at 0. So it's just going to be a generic picture. So it's going to be profile.gender. We want it to be resizable. We want it to scale to fit. And we're going to give it a frame with height of 150. Okay, and now we're going to have text again, which is going to be the name, profile.name, and that's going to have a font title and a foreground color of color.white. And then there's the profile picture. Next, we're going to add 2 buttons to change the gender. So we're going to make it an H stack. And button action, there we go. It's going to be profile equals 1. And the label is going to be, it's going to be rounded text that we made earlier. Title is going to be male. Width, it's going to be 150. Height is going to be 50. Red, it's going to be what it did before, 110. Green, 20. And blue, 205. It's just button. So there's a button for male, and it'll set the gender to 1. And we want to put a spacer right here. We want to put a spacer right here. And we're going to ditto this button, but make it a female. And then a spacer. Gender is going to be 2. And it's going to be female. And there's our buttons. And they're working. There's a male, there's a female. Next, we're going to add the text field. For inputting your name, let's get rid of this close. We don't need it anymore. All right, let's go find where the H stack started. Here's the H stack. So we're going to go, the next one's going to be a text field. And it's going to be enter your name here. And the auto completion did us good. It's going to go to the text is going to go to profile.name, and notice that it's bindable. So any input you input into this text field is going to bind to profile.name. And when that happens, profile.name here is going to get updated since it is in our model as an observable object. So when anything changes here, the view automatically gets updated. Let's go ahead and add that. Text field, enter your name here. Profile name, that's right. We're going to give it a foreground color of dot black. We're going to give it a dot background of color dot white. We're going to give it a padding of dot top 30. We're going to give it a dot padding of dot horizontal of 30. So there's the text field, and we want to give it a font. We'll do that right here. Dot font is going to be, let's make it dot title. Let's make it a pretty big font. So there's the font. Notice how when you type it in the text field, the name changes. Your name, right there. Okay, so there's the text field. Next, we're going to do the profile winnings. So what I'm going to do, I'm going to make this a V stack. So this V stack is going to have a text field, which is going to say winnings to date, and then it's going to have an H stack, which is going to have the actual winnings. It's going to have an X to erase the winnings. So there's V stack. The first thing we're going to have is a text field that's going to say winnings to date, and that's going to be dot font dot large title, and that's going to be bold, and a foreground color of yellow. And then we're going to have an H stack, and it's going to have text, which is the score. So that's going to be profile dot total score. That's going to be dot font large title for foreground color. It's going to be color dot yellow. It's actually going to be color dot white dot padding dot horizontal 30. And then it's going to have a rounded text, and it's a button. So we're going to have a button and for now we're not going to have any action. And the label is going to be the rounded text. And the title is going to be X. The width is going to be 50. The height is going to be 50. And it's going to be red, 210. Green is going to be 0. And blue, we're going to give it just a touch of blue. We're going to give it a 5. And to move the winning to date text and the score down, what I'm going to do, I'm going to put padding on this whole V stack here. So how you do that is you say dot padding, and it's going to be dot top, and let's give it 20. Let's see how far down. Let's make it 30. And to finish off the user interface, we need to add a done button. So what we're going to do is we're going to make a button, and the action is going to be is presented dot toggle. You can say dot toggle, or you can say equals false. You might as well just toggle it. Either way works. And the label is going to be a rounded text, and title is going to be done. Width is going to be 160. Height is going to be 50. Red is going to be 0. Green is going to be 200. And blue is going to be 0. And what that's going to do is when you click on that button, it is going to close down. Now, what is it missing? Oh, I have red green. It's green. And there's the done button. All right, so let's go to the content view, and we're going to hook all this stuff together. So what we have to do up here is the same thing we did here. We're going to say state object profile equals profile view model. We're going to add that right here because we need to be able to use those variables. The profile link is going to have an image, and it's going to be profile, and we're going to string interpolate it, and it's going to be profile.gender, and it's going to be resizable, and it's going to be scale to fit, and we're going to add some padding to the top, and then we're going to have some text, and it's going to be profile.name, .font, and we're going to make it headline, and the foreground color is going to be color.yellow. We need to make a button out of this, and we're going to say view model is profile presented .toggle, and for the label, we're going to give it the profile image. And all this needs to be in a V stack. We're going to add a spacer. It's a spacer between the two players. And when you click on it, the profile pops up. And now we have to tally the score. So let's do this. I'm going to search for where it says game over. And view play some game over right there. Let's see where we're at. I think that's where we got to do it. Yes, we're paying out the winner pot. When we're all done playing them, we are going to tally the total score. I can't find profile. So it's the same thing we had over here. Go to content view, go to the top. And we need to give the ViewModel access to the profile. So we'll go to the top, and we're going to do a profile right here. Profile ViewModel. Now the last thing we got to do is we got to take care of this X. What the X does is it's going to reset the score. We're doing that right here. But if you accidentally hit it, you don't want to erase your score. So what we're going to do is we're going to pop up a confirmation saying, are you sure you want to reset your score? So we're going to put a sheet right here after the opening Z stack. And we're going to call it is confirming presented. So it's going to be a sheet is presented. We're going to say is confirming. You're going to confirm you want to delete that. And what for right now, all I'm going to do is just say text. To get the placeholder, are you sure you want to reset score? Alright, so we have an is confirming presented. So what we need to do is make that a state variable. So it's going to be at state var is confirming presented equals false. Is that a minus? Equals false. And then what we're going to do on that button where the X is, when you hit the button, we're going to say is confirming equals true. And that pop-up should come up. So we're right here. So if I hit this X, it's saying, are you sure you want to delete? And since we don't have a button, you can just do that to close it. And now what we need to do is we need to have two buttons. One that says yes, and then you're going to reset total score to 0. And the other one that says no, you're just going to close down. So to make this sheet a confirmation box, what I'm going to do is I'm going to add first some confirmation text. And this is going to be the header text. It's going to say reset score. And it's going to be large title. And it's going to be colored black. And I want padding on top and bottom of 50. And then below that is going to be the confirmation text, which is going to say, are you sure you want to reset your score? It's going to be font title and color.red. The reason it's color.red is it's a destructive process. So if you click on the yes, it's going to be destructive. So now I need to add two buttons. So the two buttons are going to be pretty much identical, except for one's going to set total score to 0, and the other one is just going to close down. So everything's going to be inside an H stack, and there's going to be a spacer between each button. There's going to be a spacer before a button, spacer after the first button, and a spacer after the second button. And the button, what it's going to do is going to say is confirmation presented equals false, which will close down the confirmation box. And then the label is going to be a rounded text. The first one's going to say yes, and if you say yes, it's going to reset the total score. And the rounded text is going to have the title of yes. The width is going to be 160, the height is going to be 50, and it's going to be red. So red's going to be 200, green and blue will be 0. Then we're going to have a spacer, and we're going to have an identical button that's going to say no, except for it's not going to reset the total score. So it's going to be a rounded text with title no. The width is going to be the same. It's going to be 160, height's going to be 50, and this is going to be green. So red's going to be 0, green's going to be 200, and blue's going to be 0. We're going to have a spacer at the end and make sure everything is spaced evenly. and then a spacer at the very end to put space on the bottom. Alright, let's make sure this is all working. So let's start a game and get a score.
Ante up. Player 1. Deal the cards. Player 1. Make your bet and hit me. Player 1. You lose. Player 2 wins the pot.
Okay, we should have a score by now. He's down by 10. Let's make it a female. And the profile picture change. Let's go back to a male. And I want to clear the score. No. Clear the score. Yes. It's now 0. So it works. So the last screen we have to do is the settings screen, which is going to pop up when you hit this gear, and it's going to be a sheet. So we're going to do it just like we did the profile. We're going to make a sheet, and we're going to say, is settings presented? And we're going to do a settings view. And we're going to go to the ViewModel, and we're going to say, go to where is profile presented. We're going to change that to a settings presented, and we're not going to have a model or a view model. Everything's going to be in one file. I know that's not the way it's supposed to be done, but for simplicity and time, we're going to go ahead and do it that way. So I'm going to create a new view from a template. It's going to be a SwiftUI view, and it's going to be called Settings View. And the first thing we're going to need is, just like we did in the profile, we're going to need the binding object. And we're going to do just like the profile we did down here in the preview. We're going to create it as presented. And we're going to pass that into the preview. And it needs to be binding. And I gotta see is presented. Okay, now we have it. Let's start building it. So I have a picture of this, of what it's going to look like on the right. And that's what we're going to start building. And the first thing we want to do is we want to do the Z stack and get the green background. And we're going to give it the image green background. We're going to make it resizable. We're going to ignore the edges, just like we've done before. And now we're going to do the X, the settings, and the question mark. So we're going to do just like we did before. We're going to have a V stack for the rest of the screen. And for the button and the settings and the button, we're going to have an H stack with the button. That's going to be is presented. That's the boolean that we have here. It's going to toggle it and close this down if you hit that X. The image is going to be an X marked circle. We found that by hitting this plus button and looking at the SF symbols. It's going to be a foreground color of white. And it's going to be a large title font that determines the size of that button. Then we're going to have a text that says settings. And it's going to have a foreground color of yellow. And it's also going to be large title. Then there's going to be a spacer. And then we're going to have another button that's going to give the instructions of how to play the game. So we're going to need to add this right here as a state variable. I'm going to close this just a little bit. Maybe we can see a little better. So it's going to be state is instructions presented. Right now it's going to be false, and it's going to kick up another sheet that's going to have the settings, that's going to have the instructions, and we're going to put a padding at the bottom of 2. So let's add a spacer. Let's move this up. And then at the end of our V stack, we're going to add the sheet. And it's going to say is presented. Let's close this a little bit. It's going to say is presented, is instruction view presented, and it'll pop up a sheet when you click that button, and it's going to display an instruction view, and it's going to pass in the binding value is instruction presented. So let's go ahead and create the instruction view. We're going to say new file from template. It's going to be a view. It's going to say instruction view. We're going to create it. It's going to have a hello world, and what we're going to need is we're going to need the binding object. So here's the binding object, and just like we did before, we are going to create a previewable object for the preview called is presented. Right here, and we're going to add the is presented. And we didn't close down the sheet. And it's also instruction view. There we go. Hello world. We're going to go ahead and do the instruction view since it's so simple. On the right is what it's going to look like. It's got one image and one button. So what we're going to do is we're going to start like always. We're going to give it a background in the Z stack. And it's going to be color blue. And we're going to ignore the edges. And then we're going to have a V stack for the rest of the sheet. And we're going to have an image and a button. So the image is instructions. It's in our assets. It's resizable, scale to fit. There's going to be padding to the top of the default value, padding on the bottom of 20. That's going to be the padding between the instruction and the done button. I gave it a clip shape. It's kind of hard to see, but I did it anyway. And then we're going to add padding to the bottom of the image. And then there's the button, and all it's going to do is if you click on it, it's going to make is presented equals false, which will close down the instruction screen. And the button is made of rounded, the label is rounded text, title of done, width 160, height 50. The red is 0, the blue is 0, and the green is 200. Added some spacing to the bottom of 75. We did some padding to the top. And that pretty much is it for the instructions view. Okay, let's go back to settings. Click on the question mark. There's the instructions. And done. Closes it down. And now what we need to do is the logic for the card gap. I'm going to move this a little bit to give us some more room. So the card gap, we're going to put it right here after the padding. It's going to be an H stack. And it's going to have an image, and then a V stack, and then another image. So the H stack is going to have an image, which is going to be the 2 of clubs. It's going to be resizable, scale to fit, and padding. And card 1 is going to be an int. We're going to have to define it up top. It's going to equal 0. So now we're going to need a V stack. That's going to have 2 arrows that are buttons. So here's a button, It's going to define the card gap. It's going to have a min gap and a max gap. If you're decrementing it, the min gap is going to be 0. You can't go below 0. When you're incrementing, the max gap is going to be 5. You can't go any greater than 5. So let's define min gap and max gap. And the card gap is going to be app stored, so you can define how you want it and it'll stay that way when you restart. I'm going to give it a little bit more room here. So the card gap is going to default to 3. And there's the first button. So what this button does is if you click on it, and if card gap is less than max gap, it's going to increase the card gap. And it can't go any more than the max gap, which is 5. And the image is a chevron up square. That's an SF symbol. It's resizable, scale to fit. And the frame is going to be 85. And the foreground color is white. That determines the color of the button. So now what we're going to do is we're going to need a second button. And it's going to say if it's greater than min gap, then it's going to minus equals 1. And it's going to be chevron down. Now the second card is going to be calculated by how much the gap is. So it's going to be a function. We're going to go down here to the bottom. And we're going to create a function, and it's very simple. So the function is going to be called card2. It's an int. And what it is, it's going to be card1, which is 0. And then you're going to add the gap times 4 because there's 4 suits for each card. So if card gap is 1, then card 2 is going to be 0 plus 1 times 4. It's going to be 4. So 0, 1, 2, 3 is a 2. And then 4 would be a 3. So for the image, so here's the image, and then it's going to be card 2. It's going to go after the V stack. So it's going to go right here. And it's going to be the function card 2. So I want to add some spacers. I want one here and I want one over here. So we're going to add a spacer right before card 1. Get that off the edge, and I want to add a spacer at the end. Okay, so after the H stack, that's right here, we're going to put some text that says card gap colon how many cards. So it's going to be whatever the card gap is minus 1 times 4. So if card gap is 1, it's going to be 1 minus 1 is 0 times 4 is 0. So if it's a 2 and a 3, you can't win. Because either a 2 or a 3, you're going to lose. So the card gap is going to be card gap minus 1 times 4 cards. Foreground color is going to be yellow, and it's going to be large title. All right, next we got to get the ante and the rally amount. So let's start with the ante. It's going to go right after the text and before the spacer. And so we're going to have text that says ante. Foreground color is white. The font's title. And we're going to put some padding there all the way around. So if we just say padding, there's going to be a spacer. And then we're going to have a text field. Now this text field is complaining. The reason it's complaining, let's see what the error is. It says missing argument for parameter formatter. A text field is supposed to be a string, but our ante is an int. So what you got to do is you got to give it a formatter. The syntax for the formatter can be a little bit confusing, but what we're going to do is we're going to create a variable called number formatter, and it's of type number formatter with a capital N, and that's going to equal, we're going to say let formatter equal number formatter, And then the number style is going to be decimal, and it's going to return formatter into number formatter. And then what we have to do on the edit field is we have to tell it we want to use the number formatter, which is going to tell it that it's a decimal integer. So right here where Ante is, so right here after Ante, we're going to add a formatter, and it's going to be number formatter that we declared up here as a var, and it's a state object, number formatter. So that will allow us to bind an integer to a text field. So there's the first one, Ante, and there's a number, and then we're going to have one more of these. It's going to be a text and a text field, and this one's going to say rally amount, and the binding value is going to be start score, and the hint is going to be start score. And lastly, we have to add our done button. We're going to add a spacer, put some space here, and then we're going to have a button that's going to say is presented equals false. When you hit done, it's going to close it down, and it's going to be like we did all our color buttons. It's going to have a round rectangle that's white, and then a rounded rectangle that's green with paddings of 7 all the way around, and the text is going to say done, and the text is color white and large title, and that's going to be inside a frame of width 250, height 85, and the alignment's going to be center. And that should finish our settings. And now in our content view, where you click on the gear or the settings icon, we need to make that a button. And we're going to say is settings presented dot toggle, which will and the label is going to be the gear shape. So now when we click on the gear, the settings come up, and well, that didn't work. Let's see what's going on here. Let's go to the sheets. Is presented, is profile. Oh, is profile. This should be is settings presented. Let's try it again. Here's that. Close it down, and we're good. And then what we need to do is we need to use the app storage variables that the settings are changing, the ante and the start score. So we're going to copy these and go to our content view model, and up top we're going to add them right here. Let's separate them a little bit. All right, so now we don't need the ante anymore. And we don't need the card gap. And so the app storage for the score is called start score. So what we're going to need to do, since you can't say up here in the initialization, player 1 score to begin with is start score, what you have to do in a class is you got to call in a init, which gets called automatically if there is one. So what we're going to do is we're going to create an init, and we're going to set player 1 score to the app storage start score, and player 2 score gets app storage start score. And that should give us the app storage that will be saved across sessions for our settings variables. All right, I want to make a couple changes here, just cosmetically, before we finish. The first one is the game button. I want it to be blue instead of red. So right here in the game button logic, we're going to make it blue. The other thing I noticed is when we made the bet rounded text and made it a height of 50, you can barely see the poker chips now. So I'm going to make the height 40 for both the bet and the pot, and it should make all the images a little bit bigger. And the other thing I noticed is the slider will take up the entire view, as much space as it can. So we're going to wrap this in a frame. And let's do 300. And we're going to do the default height so it looks like all the other sliders. You know what? Let's make that 200. That's going to be a little big for phones. We want space between the two images on the betting board. And in the view model, we got a couple changes. One is this profile is declared as a state object. And if you remember when we went from the view to the view model, we changed all state objects to published variables. So we have to do that. But another thing we didn't do is we got to make sure that when the game is over, that cur player equals 1. If cur player equals 2, when we enable the buttons again, you won't see it because it's disabled always if the current player is player 2. So in a new game, player 1 is always going to go first. And also, when the game is over, I want to change the header image to in between board, which is another bitmap we have, and it'll get rid of the dealing hands. So up here at the top, this profile object, we just cut and pasted from a view, and we never changed it to published. We need to do that. And where we make our bet, there's just a slight issue here. When it gets like down to 0, he never makes a bet. And also, if it goes negative, then the bet becomes negative, and that's not right. So what I'm going to do is, if bet's less than 3 for the computer, I'm going to make the bet equal the pot amount, because when it goes negative, he's going to lose, because he won't ever. When he antes up, if he goes negative, he's going to lose the game at the end because he'll never bet enough to get out of the hole. So we're going to let him do an all or nothing here when he's negative, when he makes his bet. Actually, if it's below 3 when he makes his bet, but if it's negative, he'll get a chance to get out of the hole. The way it is now, he can't. So that's going to be one change. It's going to make it a little bit better for the computer. And for our header image and the board image, I want to make one small cosmetic change. I want to add a clip shape, and what that's going to do, the clip shape is going to be a rounded rectangle with a corner radius of 20, and what that's going to do is it's going to make the edges rounded instead of squared. And I want to do that for the header image, and I want to do that for the board image. That's just going to make it look a little nicer. And the cards sliding off the table, we're hard coding minus 500. On a big device, 500 is not going to be big enough. And technically, this variable should be declared as a variable, not as a constant. But since we're pretty much out of time on this video, I'm not going to do that. But what I want to do is I want to increase it. We're going to make it like 2500. But what really needs to be done is in your content view, when the Z stack appears, you should use a geometry reader to see what the width of your device is. And that way you can make sure you're sliding it enough. I'm going to go ahead and hard code this to 2500. That should be good for devices right now, or any current Apple device. But in the future, they may get bigger. So the way to really do this is to use the geometry reader. I'm probably going to put a video out there on YouTube and TikTok to show you how to do that, but for now we're going to just hard code it to this. And this is the last thing I'm going to do. I noticed on smaller iPhones, the player 1 score got truncated because it was large title. So what I'm going to do is I'm going to make this a smaller font. We're going to make a dot title, and I want to also make it yellow. And we're going to do that for player 1 and player 2. And this is going to be the last thing. There's probably more little things you can do to make this look nicer, or little changes that need to be made, but we're going to stop right here. This is a great foundation. You probably learned a lot. If you're new to this, it may be overwhelming. If you're not new, you may have learned a lot. But what I suggest, if you want to try to bring this further, is to make a one-player game, like we started, without any transitions, and then add the transitions to it with just a one-player game. And if you can get through that, you will probably have a good handle on everything in this course. Well, I hope you enjoyed these videos, and if you like these videos, please subscribe to my channel to help support me. And as always, from Programmer Zen, happy gaming.